we are going to start chapter 26, chapter 27, chapter 26. It's about current, resistance, and electromagnetic force. The direction of the current flow is of an external field. Electrons move randomly in a conductor. A field exists near the conductor. It follows the electronic process drift. So we have the conductor without internal field, electric field, and thereby electron without E field. The electron moves randomly. Here the mass of electron with electric field and motion is mostly random. The electric field results in a net displacement along the wire. An electron has a negative charge, so the force on its on it due to the electric field is the direction opposite to it. We have positive charge would move with the electric field. Electrons move in the opposite. The motion of electrons in a wire is analogous to water coursing through a river, and this fits the metaphor used earlier. So you have the current flow requires the conductor throughout. Here we have the current I equal D Q over T, and since dq equal Q in AV dt, so I equal N QV. So yeah, and the current density is defined as current per unit, which is Joule equal I over A, which is NQV. Here we have example with current density, drift velocity for the copper wire. So this is D. We have here the I. We have 200 uh, work, which is for I think it's for something. I don't know. So yeah, the density of free electron is 8.5 electrons per cubic meter. We find A, which is pi d, because we have here a copper wire. So it's a chemical, yeah. So it's chemical. This chemical material. Uh, by d square over 4, and we find A. After that, we find the current density, which is J equal I over A, which is 1.7 over, okay. And we find the velocity, which is V equal J over NQ. So Q, which is the charge for electron, and N, we already have it in the question. He said free electron is 8.5 times 10 over times 10 power of 28. Okay, the resistivity is intrinsic to a metal sample. Lab density is resistivity is defined as the ratio of the electron field to the current density, B equal E over G. Okay, so we have resistivity and defined as P equal E over D. And we have B for all substances. We have, for example, silver, copper, gold, aluminum. Here we have resistivity and temperature. So resistivity arises with increasing temperature, which is this one. So we use this, we have temperature, where this is the temperature coefficient of resistivity and T naught is the reference temperature. Okay. So the resistivity increasing with increasing temperature, and resistivity decreases with increasing temperature. And that's for metal, that's for semiconductor. And for a superconductor, the temperature below Tc and the resistivity is 0. Since A equal Bj, then Vn equal Bi over A, then V over I equal Bn over A, and the resistance equal R. V equal Vr or I V equal IR, and R equal R naught, and this is something for transform B, I think, for B T was T, it was V naught and V naught. We have 1 plus T minus T naught. And all the formula will give me there because we have here lower potential and here higher potential. The current flows from the higher to low, from higher to low. So it will be from this to this, and from here going over there. B potential difference between ends, and the current, and also if you let the electric field also, and I moves from higher potential to lower potential. Here, first color, green, that is uh, that is, yeah, first color band, second color band, or third color band. Ohm's law is linear, but current flow through other devices may be not be. Ohmic resistor, typical metal wire. At a given temperature, the current is proportional to voltage. I and R, right? So in some cases, the current is proportional to voltage. I think this, yeah, it's all. I mean, always the voltage is temperature with I and temperature, I mean, is proportional with I and R. If we take it is proportional. Semiconductor diode, a non-ohmic resistor in the direction of positive current and voltage I increases non-linearly with V, and here in the direction of negative current and voltage, little current flows. We have macroscopic view and the assumption that the conduction electrons in the metal are free to move like molecules in a gas leads to an expression for the resistivity of a metal, which is P equal M over A square times Nt. N is the number of free electrons, and T is the mean time between the collisions of an electron with the atom of a metal. Metal obeys Ohm's law because the mean free time is approximately independent of the magnitude E of any electric field applied to a metal. The gray line shows an electron moving from A to B, which is making six collisions en route. The green lines uh, show show the electron's path might be in the presence of an applied electric field and not the steady drift in the direction of negative E. Here we have the calculating resistance. The potential difference is set up between the inner and outer surfaces. Current will flow from the inside to the outside. The element of cross-sectional area through which the current runs dA is 2 pi LdR. So we have this one, and this is for the resistance. The element of cross-section area through which the current runs dA is 2 pi LdR. Okay. the equivalent resistance of any number of resistors in series equals the sum of their individual resistances. The R equivalent here, suppose that R3 greater than R2 greater than R1. So R equivalent is bigger than R3. I equivalent equal I1, I2, I3. V equivalent equal V1 plus V2 plus V3. Okay, so for series, we know that Q equal Q1 equal Q2. For V, we know that V1 equal V2, plus, because here we have the sum of voltage. And for C equivalent, we know that it is 1 over C1 plus 1 over C2. And here we have minus 1. But for R equivalent, it will be the opposite of C equivalent, which is R1 plus R2 plus R3. And the current here will be equal, because, for example, if we have this one, we have this voltage, we have, for example, this resistor, and this resistor, and this resistor. So all of these resistors will have the same Y. And let's move to the parallel. For a number of resistors in parallel, there is a product of the equivalent resistance equal the sum of the reciprocals of their individual resistance, which is, yeah. So here it is the opposite of series. For parallel, we know that it has the C equivalent, it is C1 plus C2. And for V, it is V equal to V2. And Q, it is the sum, Q1 plus Q2. For R equivalent, it will be R equivalent equal 1 over R1 and 1 plus 1 over R2 minus 1. And if we are dealing with the current, the I will be the sum of I1 plus I2. So that means R equivalent, it will be less than R1 or R2. And therefore Y and therefore V. So for example, this one. So the current, for example, will flow from this direction, and the R1 will not take the same I for R2 and R4 and R3, but uh, all of these resistors will have the same. I mean, the sum of them, it will be I, because I1 plus I2 plus I3 plus I4. Okay, let us there is okay, we have the conservation of charge flow. We have I equal Q over T, and we have here something called node. So node, when I think, let us check here. So the point through which a current element is connected to the circuit. The point of connection between two or more branches. Any region on a circuit between two circuit elements. A fundamental concept of a full circuit analysis representing a connection formed by element.
Identify the nodes. So this point right here, we're going to use that node to help us calculate the current in the circuit, as well as this point. Now this is going to be the ground. We're going to use that as our reference node. Now, just to keep things simple, we're going to say that the electric potential of the ground, we're going to assign it a value of 0 volts. So anywhere along this line will have an electric potential of 0. Now, the electric potential at this point has to be 70. Voltage is the potential difference between these 2 points. And based on the source voltage, we know that this has to be a difference of 70. Now, we don't know what the voltage here at that point is. Let's call the electric potential at that point VA. And the electric potential at this point, we'll call it VB. If we can calculate VA and VB, we can figure it's going to flow in this direction. Now, we know that what is the voltage across R1? So V1 over R1 will give us I1. What is the voltage across R1?
So I1 minus I2. Here I1, it is going right side. I2, it is going down side. And that's because it is possible to, or for the R2 or for the I2 to going upside, because it will be here right side upside, and this and this uh, and this current also flows on the left side. So how we can, I mean, it would be wrong, because if R2 or the I2 will flow upside, this one it has to be downside. So here we're assuming that R2 will be downside, so we write minus I2 plus I3 equal to 0. And I noticed that the node has to be connected with 3 lines. For example, this one is not, because here it is not. Here we call it node. So here the sum at node equal to 0. Here we have inner, which is I naught, right here, and here we have I2 and I1. So we write I naught minus I1 plus I2. We have I1 plus I2 equal to 0. Here, for example, we have this node. So upside, right side, and we have also here upside. So it has to be like this. Here it will be I1 plus I2 plus I3. Because here right side, upside it will be all positive. The junction rule states that the total current directed into a junction must be equal to the current directed out of the junction. Okay, the junction rule. I will fill the junction rule. Okay, which is about the Kirchhoff's current rule. Okay.
Zyrtec for a fast and effective relief of allergy symptoms in 20 to 60 minutes. Zyrtec can reconnect.
Now let's work out a basic example. So here's the junction. Let's say if we have 10 amps of current flowing in this direction, and we have 4 amps of current flowing in that direction. Let's call this I1, and this is going to be I2. Now I1, is it equal to positive 10 amps or negative 10 amps? Because the current is flowing into the junction, that's in this region, this is going to be positive 10 amps. Now what about the 4 amp current, I2? Is it positive or negative? Now that current is leaving the junction, it's moving away from it. So this is going to be equal to negative 4 amps. So now let's come up with an expression that will help us to calculate I3. Now before we do so, take a guess. I3, is it flowing into the junction, or is it flowing out of the junction? Now once we calculate I3, if it's equal to a positive value, then we know that the current is flowing into the junction. If I3 is equal to a negative value, that means that the current is flowing out of the junction. So we said that the sum of all the currents must add up to 0. So that means that I1 plus I2 plus I3 is equal to 0. Now I1 is positive 10. I2 is negative 4. So now let's calculate I3. So 10 minus 4 is 6. So if we move the 6 to the other side, I3 is equal to negative 6. So what this means is that the current is flowing away from the junction. It's going in this direction. So notice that the total current that enters the circuit, that's positive 10 amps, that's equal to the total current that leaves the circuit, which is negative 6 plus negative 4, which is negative 10 amps. So everything is balanced. Now let's consider another example. to determine if the currents are positive or negative. So this current, the 10 amp current, is entering the junction, so that's
To be
positive.
positive
The
and
14
then
amp current is
negative.
leaving the junction, so that's negative.
Yeah, it's
So we say
away.
that I1 plus I2 plus I3 adds up to 0. I1 is 10, I2 is negative 14. Now we need to take this number, move it to that side, where it's going to be positive 4. So I3 is equal to positive 4 amps.
Oh,
So equals,
here.
and let's call it I1. And let's say we have a current of 9 amps flowing in this direction. And so we'll call that I2, and it's a current of 7 amps. Go ahead and try this problem. So just like before, let's write a simple expression. Let's add up each current and set the sum equal to 0. I1, is it positive or is it negative? Now notice that the 8 amp current is leaving the junction. It's moving away from it. So therefore we need to assign a negative value to it.
Yeah.
Now, the 9 amp current, I2, is going...
That's because any or any current that moves away from this point, it will be negative, and any point that is any points that are moving in this point will be positive.
going towards the junction.
So this positive here positive, here negative, and I4 it will be variable, so you have to find I4.
8, which means I4 is equal to negative 8.
Yeah. So it will be negative, and it will be away from, it is moving away from this point. Okay.
Plus 9 and plus 7, so that's a total of 16 amps. And the total current that's leaving the circuit, I'm going to highlight that in yellow. That's negative 8 and negative 8 here. So that's a current of negative 16. So the net current that flows...
So here, he calculate the inner current, the outer current, and I think to be 16 equal negative 16, because the lecture will say that here the current directed into a junction must be the equal. That means inner equal outer.
Flows in a junction is 0, which is what it's supposed to be. Now, for the sake of practice, let's try one more example. And so here's the junction. So let's say if we have a current of 12 amps flowing in this direction. So let's call that I1. And let's say a current of 8 amps. And let's say that we have a, and let's say that the magnitude and make
so you
is what it's supposed to be.
Yeah.
Actually, let's assume that it has the same direction. Let's keep it simple. So with this information, go ahead and calculate I3 and I4. So calculate the value of two missing currents. So first, let's write an equation. I1 plus I2 plus I3 plus I4 and plus I5 must equal to 0.
0, yeah.
So I1 is positive because it's going into the junction, and I5 is also positive. I2 is negative. So I1 is 12. I2 is negative 8. We're going to leave I3 the way it is. Now I4, I'm going to replace it with 2I3. And I5 is...
Yeah, 2I3 because it is given in the question here. He said that I4 equal to 2I3. So here he given to you like information that I4 is equal to I3, and that means I4 equal to I3, and we don't have I4
is positive 20. So let's add like term.
20 for what? I5, okay. Yeah, okay. So here I3 and I4 are variables, okay. We don't know I4, we don't know I3, but he said that I4 equal to I3. That means we can change I4 to I3 and I3 with I3 itself. So to be 3I3, and we have to find I3. After that, I3 it will be, for example, to be 12. I4 to be the double of it, so to be 2 times 12.
12 minus 8, so 3I3. Now going away. Now let's compare the total current that flows in the circuit and the total current that flows out of the circuit. So the total current that flows in is going to be 12 plus 20.
Yeah, 2 times 8 will be 16, but here that in the negative side. That's because the I3 was equal to negative 8. Okay, so it is like no any it's like the sum of I equal to 0, or you can write it as the inner equal to the outer, but the sum of them to be 0. And for example, if you find I in that 16, okay, and I out negative 16, so it will be 0. Here we have for the V here. Yeah, here the Kirchhoff's rule for the it is second law. It was something I don't know. I will check here. Kirchhoff rule for units. Yeah, here for the voltage law. Let me see. I hope the sound
In
is
this video,
really
we're going
good.
to go over
It's
Kirchhoff's
share
voltage law,
because
abbreviated KVL.
we have audio output. Yeah, it's fine.
Now, his law states that if you have a closed circuit, the voltages around
I think I will stop here. I will. How can I? Yeah, yeah. I will pause it now, and I will be continuing after 20 minutes. Okay. Okay, so we continue now. Here we
on
can
that
check
circuit must add up to
voltage.
0. Now, some voltages are positive and others have a negative value. So you need to determine which one are positive and which ones will be negative. Now, let's say if we have a resistor, and let's say this is at 20 volts and this is at 10 volts. You know that current naturally flows from the direction of high potential to low potential in a resistor. So it flows from positive to negative. Now, a resistor consumes energy. And anytime the current flows from a high electric potential to a low electric potential, the energy of the charges that are flowing in that circuit is actually being reduced. Energy is being transferred from the charges to the resistor. So therefore, because the resistor decreases the energy of the charges, we're going to assign a negative voltage to it because it reduced the energy per unit charge. And that's what a volt is. 1 volt is 1 joule per coulomb. So voltage is basically the energy change per unit charge, which is basically per 1 coulomb. Now a battery does something different. In a battery,
Yeah, I think I don't have to this to see this video because I know it already. For example, here we have here positive and negative, okay, and this always moving from positive to negative. So it will be from here it will be the moving here counterclockwise, and if we have to, yeah, so this is E, the electric field. So E here we have R1. So assume that I is moving with this side and here from this side. So if if we moving if the electric field move with the same direction of the current, it will be negative. It is if it is moving with negative, I mean opposite direction, it will be negative. And this actually will be discussed in chapter 27. So it will be uh, here, here positive, and here same direction to be negative I1 R1 and negative I2 R2, and it will be equal to 0. Here we have series, series. So R equivalent will be R1 plus R2, and for I it will be same. Yeah, so I1 equal I2. That means we don't have to write I1 I2 because they have the same I. So yeah, so it will be like this one. Next, okay. Here we have this one. So here it's moving in this way, and in this point it will be 12 volt. At this point it will reduce to 8 volt and will be stable until it is uh, arrive in this mode. It will be 8 volt and it will be reducing until it is reaches to the zero. Energy conversion and power input to a source. Here battery small m and alternator large m. External circuit and source of internal resistance. Electrical power P equal VABI. So B it will be VABI or I square of R or V square over R. The electrical power output of the source equal electric field minus I square R, when the term EL is rate of the energy generation in the source and I square is the rate of energy dissipation, which is the consumption. Find the rate of energy generation, rate of energy dissipation, and net power output of the battery. So this is okay. We have this voltage, we have I, and this is moving. That will moving counterclockwise. Here D equal I square R. VI mean B, so B equal V I square R. Yeah, I will skip it. I will just move to the 27 here. Fair 27, which is direct current circuits. Okay. It's called electromotive force. So electromotive force, I will search for it. It is the maximum potential difference across the terminal. Is energy per unit of charge that is provided by a source, such as battery or generator, to drive a current through a circuit. It is measured in volts and is symbolized by the letter E, or this one E. I think I have I will check now if I have because I have a file about 27. So after we finish this one, I will move I will move to it. So here for any open circuit, due to internal resistance in the battery, the voltage across the terminal is less than MEMF. So E equal I, yeah. So V equal E minus R. The car battery has an electromotive force of 12 volt and an internal resistance of this, which is the terminal voltage when the current drawn from the battery. So we have A and B. So if the I is equal 10 and if I equal 100, so we have to find the terminal voltage, which is V equal IR. So it will be 0 and 10, and then we have to reduce this E minus V. Where is it? Yeah. Just like B equal, or here it is E minus V equal I R. Same thing here, and we have 11.9. Here 1 volt, so it will be 11 volt. That means if we have 10 uh, 10 current, it will be 11.9 voltage, and for 100 it will be 11. Okay. Here it is shortened samples or in use for all wiring components. Here we have a conductor with negligible or negligible, I don't know, I think negligible resistance. A resistor, we have the voltage or source of electromotive force, which we call it E, and we have this one source of electromotive force with internal resistor, and here are can be placed on either side. I mean, in the negative or the positive side, I think, yeah. We have voltmeter. We measure the potential difference, which is V, and a meter, we measure the I, which is the current through it. And this is very important to know. Voltmeter measure V, and a meter measure I. Kirchhoff rules. We have junction rule and we have loop rule. Junction rule we already covered in the 26. Here the sum. Let me write that this one. The sum of I equals 0, which means the inner of uh, the current equals the I outer. And they have to, and the sum of them to be 0. So the sum of the magnitude of the current directed into a junction, which is the inner, equal the sum of the current directed out of a junction. Here we have the loop rule. Loop rule actually is around any closed circuit. The sum of potential drops equal the sum of the potential rises. And for loop rule, it is the sum of the potential rises equal to 0. If, for example, if we So here it will be moving like this because we're moving from positive to negative, and I this moving also counterclockwise. If we want to find a loop rule, so it will be here E, so it will be E, same direction, it will be negative I R1, and and here also it will be here I, so it will be also negative to R2, it will be 0. I just want to know if it is parallel or not. I think it is parallel. Yeah. I'm sorry. It is series, and that's because here it is just like this one, like this. Uh, here it is just like this, but yeah. So this is so he put here a meter to measure the current I, and he put a voltmeter here, voltmeter to measure what? To measure the to measure the voltage. Yeah. So here it is just like this one, but so it is series, but he connected it with a voltage or voltmeter. Sorry, voltmeter and ammeter. Helium the ammeter. So here he put voltmeter and ammeter, and he put here ammeter and voltmeter. But what is the difference here? Why he put it here and he put it here? This same thing, but I don't know. I will check now to know. I think it's something. I will ask. I think no. Yeah, this one. To if the two circuits are the same, I mean, if is the circuit. Uh, I mean, I think that two identical voltage, so the same thing. Yeah. What is the difference of bond of putting voltmeter in the circuit and second and in or out of the circuit? So here the purpose of the voltmeter replacement. Inside the circuit, if the voltmeter is related directly across R, measure the voltage drop due to the circuit. At the place terminal, it will measure the terminal voltage, which can determine resistance drop. Okay. So this one, which is out one, it will measure what? The current or the voltage drop due to the current volt. And here also found the internal resistance drop. Here came the voltage drop into the current and become the internal resistance drop. No, no external resistance mean what? I don't know. Just say yeah. So I said here the circuit is effectively short circuit. Short circuit because there is no load resistance and all voltage is dropped across the internal resistance. So this scenario is dangerous in real life batteries because high current can overheat and damage the battery. And this is why you have to, yeah, so it will be high voltage and it will be overheat the battery. So it's like dangerous thing. Next, yeah, skip it. Yeah, same what we did, electrical power, and here also we covered it. Or no, it was for, I think, what it was for, let me see, here, okay. So here you have electrical power, okay, minus I square R where term rate of energy generation and the rate of energy consumption. Here I will skip this one also. Okay, this is important thing we have to know. Resistors in series and parallel. I will be back within 10 minutes. Or not now. It's fine now, yeah. Okay, if we talk three resistors and consider the different ways they could be connected, we arrive at the four possibilities. So here RT equal R1 plus R. So this because you have in series. So this is in series. Second one, it is parallel. We can ignore this one and you can write yes, we can write the equivalent. It will be what? Uh, I mean here, sorry, I mean here, yeah. So here it will be R1, R, and here 1 over R2, and also for R3. The whole minus 1. Here we have here 2 parallel, and we have 1 in series. So it will be R equivalent. Actually, you can find first R2 and R3 and then finding the R1, but we can write it as, or no, it will be here. I think it is better. It is better to find, or it will be like R1 because in series plus 1 over R2 plus 1 over R3 minus 1. For this one, here in series, so it will be like this after we find it, and we have this, so it will be parallel. So you can write it as R equivalent. For this, it will be R2, R3. So R2 plus R3 plus 1 over R, R, it is better to write as this. It will be here R1, R2, right? R2, R3, it will be this one, right? Okay, so to have the parallel, it will be 1 over R2, R3 plus R1 minus 1. So this is the R in series, and then we counted with the parallel R1. Circuit analysis strategies. So you have 4 ohm, 6 ohm, 3 ohm. Here we have to find the parallel. Here we have parallel. So 1 over 6 plus 1 over 3. All of them are uh, are on power of minus 1. So it will be 2 ohm. And here 4 ohm. Here series, so 4 plus 2, it will be 6. And to find the voltage for this one, so it will be, here we have ohm, we have voltage, so you can find R, which is V over R. So 18 over 3, it will be 6 ampere. Or okay, 6, it will be 3 ampere. And to find for this one, we know that in series resistor, it will be the same ampere. So if this one is 3 ampere, so we can write that 3 ampere here and 3 ampere here, because we already found it for the sum of them, which is series. So series have same I. Okay, what about the voltage? Is it the same? The answer is no, because in series we know that V equal V plus V1, and V1 plus V2. So we can find for this one the voltage, which is 3 times 4 and 3 times 2 for this one. So it will be 6V, sorry, 6V and 12V. And it is already right. It is already written here. Okay. If we have parallel, what it will be? We know that 3 ampere. Okay. Here the question is that is it also here 3 ampere for those? Actually, it will. I don't know. I mean, here we know that it will be the sum. Okay, so here I am talking about the I. For parallel, we know that I equal the sum, which is I1 plus I2. So how we can know if 6, so we have 3 ampere, okay? So it will be, so here the question is how we can know that, so yeah, as I said, we have 3 ampere and we want to divide it into 2 resistance. So here, how do we know if we have to find if 6 ohm will take 2 ampere or 1 ampere, or when it will be divided by 2, so it will be 1.4, I mean 1.5 for the first resistor and 1.5 for second resistor. The thing is that here we have 6 ampere and we have voltage 18. So first we have to know what is the voltage here. We know that it will be 6 here, 6 volt, and here it will be 12 volt. If we have it in parallel, we know in parallel we have same volt, right? Excellent. That means 3 ampere will take 6 volt and 6 ampere and 6 ohm, I'm sorry, it will be 6 volt. So how do we know the I? We can find the I that it will be 6 over 6, so it will be 1. And this one, it will be 2, because 6 over 3, it will be 2. And the thing is, if we have higher ohm, it will be less, and that's because the relation between I and R is not proportional, because if we have higher I, R it will be less, and here we have higher R. That means we will have less I, which is 1, which is 1 ampere. Here we have less R, so we have 2 ampere. The thing is, if we have 6 ohm for both if we have 2 resistance and both of them have same ohm, for example, it's 6 ohm. The thing is that the two of them will have the same ampere. Because we have the same volt and same, so it will be 1 ampere and 1 ampere. That will happen if we have same ohm or same resistance, I mean. And 2 ampere, 1 ampere. And for this one, so here series will not take the same voltage, but we know that it will be 12 here, right? So here we have 12 volt. So we can find I. 12 over 4 will be 3. So 3 ampere. And this one, it will be 2, and here 1 and 2, and some of them it will be 3. Here the algebraic sum of the current into and the junction is 0. So here what we have, yeah. So we will stop here. Okay, so search of rules for the junction. First one for the I, we know that if we have, for example, here it will be I1 plus I2 minus I1 plus I2 equal to 0. Here if we have this parallel of this loop, we can say, so that means we have three loops, because here we have one loop, and here we have one loop, and we have this loop, and we can use the Church rules too. It's about the volt, um, and this one, and this one they call it something I don't remember, but yeah. So this is series R2 and R1 series, and uh, it is actually like this one. What is bad drawing? Okay, so here we have one, and here we have one, and here we have one, and here we have one. The thing is, this and this are parallel, and this are parallel, but the thing that is ruined everything, which is R. So R1 and R2 in series, R3 and R4 in series. We will see how to calculate it. The algebraic sum of the potential difference in any loop, including those associated with electromotive forces and those of resistive element, must equal to zero. And this is the Kirchhoff rule, as we said, the, the rule number 2. Here we know that so it travel from positive to a negative. So it will be positive here. Here it will be positive, or I mean, here travel direction from positive to negative. So it will be this. So yeah. That means because it travel in the opposite direction. Because the normal direction it travel from positive to negative. But here it will travel in the opposite direction, so it will be negative B. Here, if E is travel in the right side and the current direction is travel in the opposite side, in the opposite direction, so it will be here positive. And here in the same direction, it will be negative. This means negative volt, and positive volt. And here also it will be negative volt. No, it's not negative volt. Okay. Three unknown currents. So we have here this parallel. So we have three loops. Um, so we have the unknown current, which is I2, I1, I3. So we can take this side or this side or this all loop to find it. So here if you assume that it will travel in this side or it travel in this side, same thing. I mean uh, clockwise or counterclockwise, it will be the same. Let us take an example here. Find I, R, and E. So we have three unknowns, and here we have this circuit. We have three loops. Here we have this 1 ampere, and 3 ohms. Here we have 2 ampere. So we can find E actually. So we can take this one and finding E. So if it travel uh, clockwise, so here it will be negative E. So it will be negative E, and here it will be moving in the opposite direction, so it will be I. Here in series, I have to write I1, I1, R1, if I assume this R1, or this I1, yeah, this I1. Oh, no, it will be same thing, yeah, I forget. It will be same thing, okay, because in series, we have this R2, here R1, and it will be in the that will be minus I R2. Let us see. I it will be 1 and R1 it will be 1 also. Minus I, which is here 2. Why is 2? Yeah, because it is parallel to this one. Yeah, I see. Okay. Equal to 0. Correct the calculator actually. Here 1 minus 6 will be negative 5 minus 5. Yeah, it will be minus 5 volt. Yeah. So E is equal 5 volt minus 5 volt. If I take this one, so here we already have E, but we don't have I, so we can find I here. And it travel clockwise. So E minus I 1 R1, and here also minus I 3 R3. So E minus 3 volt minus I1, which is 1 times 1 minus, here we don't know, and we have here volt. Actually we cannot, I think, dealing with this. I mean, if we here for 3, where is it? Here it will be, I think it will be right, yeah. So here it will be positive, positive here also. So it will be here, but we don't know the ohm, yeah. Don't know the current. Here we didn't know the current, and we don't know the resistance. So you have 2 unknowns. Here I would move this thing, and I will dealing with the outer one. So the one here, if I am dealing with one, it will be clockwise positive, and here negative, and negative also. Yeah, so it will be 12 minus IR. It will be what here? So complicated actually. And here it will be 2 times 3. Here we have 2 unknowns, right? But here he said 3R. Why? How you find 3R? Okay, so he find 3A. Okay, I see now. So he first calculate so he using the junction rule. So he said for I, we will Like for example, we will take point A and we will see now. Okay, so point A. So first, it is better to dealing with um, the I to find the unknown I. So here we have this one 2 ampere. So here we have 2 and it is in 2 ampere, and here 1 ampere, and here it will be I. So we can say minus I 2 plus 1 equal to 0. So it will be negative. Yeah, no, it will be positive 3m. So this will be 3m. That means it will be 3r equal to 0, and we can find r, which is 2 ohm. So we have the volt, we have ohm, and we have to, and we already find 3m. Yeah. So first of all, we have to find the junction rule, and then you can find the all unknowns that you didn't have. I had a stomach ache. I don't know what's going on, so I think I will pause now. I don't know. I'm sorry for that. I will pause now for just 10 for just 10 minutes, and I will come back. Okay. Find the current in every resistor and equivalent resistance. So here we have 4 loops, because here we have also loops, but T is dealing with 3 or 3. I don't know why. Let us see. I think the doctor on the lecture said if we have 4 loops, we'll use only 3. Okay. So here he is dealing with I think first one. Yeah, so we come back. Okay. So here he first, let me check here. Here he using 1, 2, 3. Okay. So we are dealing with first one. So first one we have positive E. So 13. Here we have minus I times 1. Same direction. Minus I1 minus I what I minus 1 times I1 minus I3, and then here we have same direction also. So I don't know why he skipped this. Why he skipped this one? But I think this is for the loop 2. No, I don't know why. Here actually we don't have resistor, so let us ignore this. Okay. For the second loop, it will be 13 minus I2 times 1 and minus 2 times I2 plus I3 equal to 0. For the third one, it will be, let me check. So here I2, I1 minus 1 times I3 minus 1 times I1. But here I will check that, why he doesn't use the for loop. So we will check here. I think he had what it is here. Okay, why he didn't use for loop? Because he used in the given circuit only 3 independent loop equations are needed to solve for the 3 unknowns. Let me check. In this loop we didn't have anything, right? We have, but I think we can. I will check here. Can we use for loop and or instead of the third loop? I think we can. I think yes, yeah, you can replace the third equation with the fourth equation, but only if the new loop provides information. Okay, so we ends up with these equations. Here you will use the third one. Okay, as we said first, you have to. I don't know what's going on. I think the battery here, how much is it? 29. And you have to. Okay. Actually, there is no sign on my PC that shows the laptop has to be charged. I don't know why. Okay, so here we are dealing with, or we are doing the Kirchhoff rule 1, which is for the kernel. So here he said I2 equal I1 plus I3. So using third one, or third loop, so we'll have I2 here minus I3 minus I1 equal to 0. So I2 equal I1 plus I3. Okay. So I2, we don't have I2, right? Okay, so let's keep it here, okay, like this. And we are moving to the first one. First equation, which is 13 minus 2I1 minus I3 equal to 0. Okay. And we have this one. Okay, let me check here. So yeah, I will write it and I will see. So here we have this one minus. I don't know why he said 2I1. Why? And where he get I2 or 2, yeah. Okay, so this is for, so here it will be I1 minus, here it will be, here minus will be, and so it will be here minus I1 minus I3 equal to 0. So E13 minus, here it will be this, it will be I1 minus I1, here positive I3, 2 I1 plus I3 equal to 0. And we can, yeah, so we end up this one. So this is for the first one. For the second one, we can simplify it. So we have to simplify it here, okay? I will simplify the second one. Minus I2 minus 2 I2 plus I3 plus 13 equal to 0. So it will be minus I2, 2 I2 and 2 I3 plus 13 equal to 0. Here we have, so this will be negative, sorry. Here it will be 3 I2 plus 2 I3 plus 13 equal to 0. Okay, so he ends up with this. Is it correct? I don't know. Here he said 13 minus I1 and I mean, when we get I1 here, I1, where is I1? Then there's no I1 here. He said 13 minus 3 I2 and where he find 5 I3. There's something weird here. Or I think he replaced I2 maybe. That makes sense actually. Yeah. I mean, yeah. So I2, he replaced I2 with I1 plus I3 plus 2I3. Hmm. Let, let me check. Is this? So this is right. I mean, how you find 5I3? It will be minus I3. Let me check again. I2 minus I2 minus 2, I2 minus 2, and 3. Yeah, so it's minus, sorry, here minus, and it will be minus here. Okay, minus, minus, and this minus. So minus minus will be minus 5 I3 plus 13 equal to 0. That's right now. So for the second one it will be 13 minus 3I1 minus 5I3 equal to 0. For the third one, yeah, so using the third one to, yeah, so the third one will be minus I1 minus I3 plus I2. And you get I2 will be I1 plus I3. And using this formula to help us to find, or use this formula for the equation 2. Yeah, so we have 3 equations now. And actually this is not important. You can actually find it by using the calculator. I think it is mode 5 2. If it will be a 3 matrix. I will check now on my calculator. Let me give me a second. Yeah, so my calculator is Casio. It is same. Okay, so any calculator that is from Casio and it is gray, a gray color. So you have to mode 5 2. So as you will find this one, we have here for A and B, C and D. You have this one, and you have to fill each one with their own. So I will use it now. So I will start with the first one. So I will here write 13 negative 2. I just write the factor I3. I don't know. I mean I2. I will write 0. I think, and for I3 I will write 3. Second, where is it? It was here. What? Second equation, where is it? Yeah, here. So here 13 minus 3, 0, minus 5. And here I will write 0, 1, 1, 1. It has to be the first one would be 1.4, 8, minus 7. Okay, so Wait for a second. There's something wrong here. Okay. For the last one, I have to write it as 0 minus or plus I2 minus I3 minus I1 equal to 0. It will be here -1 and -1. Okay, I have to check for the first one. Do we have I3 equal to something 1? No. 8? No. 9? No. I don't know what's happening right now. I think I have something here, or I think I have to start with first one. I don't know. Something next. Oh, okay. 13. It's like it is D. I mean here 13. Here 13. We have to write 13, and here 13, and here 0. Okay. And this I1, I2, and I3. Okay. So for the first one again. Okay. So it will be -2, 0, 1, 13. For the second one, it will be -3, 0, -5, 13. Second one, or last one, it will be 1, 1, 1, and 0. Yes. What? So here is said I1 will be -6a. Let me check. I think because I write 1. Yeah. I have to write -1, -1, and 0. Again, okay. I2 will be here -7 ampere, and I3 will be 1. I think I have something wrong. I mean here I3 1, I2 is not -7a. Okay, I will ignore my solution and I will follow his solution. So I will write this. I will start with the first one. So it will be okay, -2, 0, -1, 13, -3, 0, -5, 13. Here we have, yeah, -1 first, 1, minus 1, and 0. Right? Oh my god, shut right. I don't know. There's something weird happening now. -2, 0, -1, 13, -3, 0, -5, 13. Here it will be a -1, 1, a -1, 0. I don't know actually, I will check it in the DeepSeek because there is something wrong here. I will check it quickly because I have to go right now. And I will pause the. Okay, same thing we. But he. Okay. I mean, solve it from the calculator. Mm. Okay, I will pause now and I will continue because there are many things that I missed here, so I will pause for now and I will come back at half hour. So I will pause now. Okay, so we came back now. So we just talked at when. Sorry. Okay. Okay. When we were having uh, three equations and we put it in the calculator, but we didn't receive the correct result. That means there's something wrong here, but yeah, so we have this one, equation 1, equation 2, and equation 3. Solve equations AB for 1. I mean, I don't want to solve for anything. I just want the the correct answer. I mean, why he doesn't? I don't know what's going on, but he's solving manually as it should. I asked him to find 3 unknowns by using the calculator. So we have this equation, these 3 beautiful equations. I would just compare it with my own solution. So for the equation 1, it will be minus 2. I don't know how he get positive 2. I don't know why. I think there's something wrong here. I don't know. Or maybe he moved negative 2 on the other side so that he will receive 2i and here minus I3 equal 13. Okay, and for this one also I think. Yeah, so this will be 3i minus 5i or plus equal to 13. This will be, yeah, so it will be I2 minus I1 minus I3 equal to 0. If we solve for each one, he said mode and stimu. What is stimu? Mode, STMU, what does that mean? STMU, what? I cannot find it, but I think that we have to find. Let me check. Okay, if I write those equations in the calculator, so let us check. So 2, 0, minus 1, 13. And we have the second one, which is 3, 0, 5, 13. And we have negative 1, 1, negative 1, and 0. Yeah, okay. So the reason why we get wrong answer because we didn't let us say rewrite the equation correctly. So after we find 13 minus 2i1 plus I3 equal to 0, right? So we have to rewrite it so we can let us say So we can keep 13 and move these to the other side. So it will be 2i1 minus I3 equal to 13. So this is for equation 1 that we have to uh, to write it in the calculator. And this for second one, same thing. So it will be 3i1 plus 5i3 equal to 13. This is 1 and this is 2. For third one, it will be I minus I1 plus I2 minus I3 equal to 0. This is the third one. Okay. And then you have to use mode 5.2. If you don't have the gray one, you have to receive this structure when you have A, B, C, and D for three lines. So here you will write 2, 0, minus 1, 13, 3, 0, 5, 13, and you have here minus 1, 1, minus 1, 0. So, and you will receive I1, which is 6 ampere, and I2, which is 5, and I3, which is minus 1 ampere. Let us check if we yeah, right, no, yeah, yeah, it's right. 6A and I2. Let us summarize what we do in this question. So in this question we use three loops to find I1 and I2 and I3. So I will rewrite it again instead of okay, it will be so for one here you will receive 13 and minus I1 minus I3, and it will, yeah, so this one, and you already have, yeah, and we have I1, yes, it will be I1 times I1, which is I1 equal to 0. So here we have I1, so yeah, so um, so we so we um, so we end up with this equation. For 2, it will be here positive, so it will be 13, and we what? Okay, so we have this I2 and I3, so it will be negative I2 times 1, I2, and we have in the same direction minus 2. So here it will be minus 2 I2 minus I3. So I have to uh, to uh, I mean 2 will be here I2 plus I3. So 2 will enter to the I2 and I3. It will be I2 plus I3. and here negative, so to be negative here. Okay, for third one, for the third one it will be, let me check, third one it will be what? Here I2 minus I1 minus I3. And the thing is, if we calculate, so here, yeah, so for this one it will be 13 minus, so this will be inside these, so it will be positive, I think. Okay, negative. Here also plus, I think. Here actually you have to write it. Okay. Okay. Here it will be 13 so 13 minus, okay, minus I1 minus I1 plus I3, because negative will enter for both of them. 13 minus 2I1 plus I3 equal to 0. This is for one. Second one, it will be 13 minus I2 minus 3. So here I2, here it should be 3. So we will continue now. Second equation, it will be 13 minus I2 minus I2 minus I3, which is equal to 0. And for third one, it will be I2 minus I3, I1 minus I3. Okay, we have to rewrite it. For one, it will be 13. For the second one, it will be here I2 minus I2. Here I2 minus I3 minus I2. Let's check here. Yeah, exactly, minus I2. Yeah, so to be like this. And we will replace I2 by I1 plus I3. Here I have question. If I didn't replace anything, does the result be the same? Check here. I don't know actually. I'm confused now because why he replaced I2 by I1 plus I3. So if, okay, I will use this one, so it will be 3I2, 2I3, and equal to 13. Okay, we have the first one, which is yeah, so oh my god, what's happening right now? Where is it? Yeah. Okay, this is the third one will be what? I2 minus I1 minus I3. It will be 0. I will check my calculator. So here it will be 1, 0, 3, 2, 13, 2, 0, 1, 13, 1, negative, or I mean, let me write that. So it will be negative 1, 1, and negative 1, 0. But it's not the same. Why? Okay, first one it will be the same. Okay, first one will be this. So let me check now. It will be 2. Since there is error, I don't know. I mean, why we didn't take this one and without replace I1? Minus I1, I3 equal to 0. For second one, it will be 13 minus I2 minus 2 I2 plus I3, right? I2 minus I2 minus 2 I3 is to be 3 minus 3 I2 minus 2 I3, and this is without replacing anything. So the first one will be what? I mean here. So it will be 2, 0, 1, 13, and here it will be, here it will be 2i3 plus 3i2 equal 13. So it would be first 0, 3, 2, 13, and we have 1 or negative 1, negative 1, 1, negative 1, 0. It's not same. I don't know why. I don't know why actually. I'm confusing. I don't know why. Let me check here first. See how many. But I mean why? So I mean we have to set a number of the variables that is unknown being more. So we have to write 2 only. But actually in the third one we have I2, I1, I3. Doesn't make any sense. Yes, I have 2, I3. Okay, I will ask him if I can replace. Can I place I1 and I2 anyway? Or no, because you have I1, I3, so you have to replace here because we have I1, I3, so we have to replace them by this I2. Okay, I get it now. I get it. Okay. Here we have R. So what that? I mean, So RC is not included. So this is not included in our section and the sound. So we have this R side galvanometer. The meter is side of wire mounted next to a permanent magnet. Okay, any current passing through the soil will induce magnetism in the soil.
Action. Okay, okay, give me a second because so this is battery. I lost the battery of my AirPods, so I have to connect with this left one. I hope the sound is fine now because the previous video it was my sound was I actually cannot hear it. I have to increase the sound so that I can hear myself clear because actually that time I was not wearing any
AirPods, so that's why it was hard to to hear myself. Okay, so I will now I will continue now. I hope um, uh, I hope the sound is clear now. Okay, so here you have the any current passing through the soil will induce magnetism in the soil. The interaction of the new electromagnetism and the permanent magnet will move the meter indicator mounted to the soil. The ammeter, sometimes prefixed with milli or micro because of the currents to be measured are routinely thousandth or millionth of an ampere. May be used to measure current or and yes, I think we have the ammeter. I think the ammeter is that was measuring the the current, yeah. Or what that mean? Oh, okay, okay, measure current or voltage. Okay, now I will pause now, and oh, I think I will. Here I have some files. I will check if I have file about chapter 26, 27. Unfortunately not. I don't know why. I mean, we have. I don't know what's happening. Okay. conversation. We are talking so much, so I can see the points. And this is yeah, in the homeworks, underneath the homeworks. This bank, what happened? This see. Okay, I have for chapter 27, 26. It's there was a student. She's making a note, a good note for the for this. So I will share it now. I just want to make sure everything is right. So I will, yeah, on Telegram. Yeah, so this one, chapter 26, 27, I think. Yep. Yeah, that is. So this is not what? Okay. I will ask if someone have the notes. Okay, I have. I mean, let me check. Here for Felix 2, yeah, for Felix 2. Professor Maria, Professor Maria, we talked with him for chapter 26, but I will see the slides first. It's a tutorial session. Tutorial session. I think it was here we have worksheet. So fluids, jihad, Friedman. Okay. I need slide like note, like someone write them. I don't need anything like jihad, we have also jihad. Same thing. I'll check if I have here. Damage care. I can same thing here. I feel the same, yeah. Yeah, the same thing. I delete it. This we have more, so I'll click for physics 2. And we have to, okay. So we have 26, 27, I will download it. And for anything related to 26, 27, 26, 27, 26, yeah, please, yeah. 26, 27, then what we have for okay, this is it. 19. So I will see it. Okay, so chapter 26. Here we have chapter 26. Lecture. Okay, so we have here ampere for current because this I V over R and average current is Q over here V over Q, V over R. I think this is another one. Okay. Here I give us the charge and we have the current. So to find I, it will be dq over t over dt. It will be 60 minus 2, and he would ask you to find the current at t equal s, at t equal 2. So replace t with 2, and you will get 10 ampere. And if he asks about the average current, it will be the same thing. The problem here, we have I, and we ask about the change of charge. So Q equal what? It has to be I T. So it will be dq over I dt. So you would take the derive of this and you would, or integration. I don't know why integration. Integration because yeah, because you are not doing uh, you are not derived dq with dt. You are integrate dq with dt. And I mean, see, if you have, for example, a equal dq over dt, this for derivative integration it will be like a equal dq or dA with I, or anything like that, anything that is like this formula will be integration, and this dq over something over dt to be derivative. You have to take a derivative this case, you have to take the integration, and then you have to replace t by 2, I think. Yeah, 2. Okay. Here we have the node, the current, and okay. So it is it is about when you have the I for inner and equal I for the outer. So you have I naught equal I1 plus I2, and the both is called junction. Here I1 plus I2 because it is the sum. Okay, so it is sum of inner and sum of outer. And yeah, and if you take these in the other side, it will be what we call it the first rule of Kirchhoff, which is about the junction rule, which is I naught minus I1 minus I2 is equal to 0. Engineer 1, we have this one. He said, yeah, same thing, what we call a junction rule. Here, the figure here shows a portion, or I think portion here, I don't know why. Okay, of circuit, what are the magnitude and direction of the current in the lower right hand? Okay, so okay, actually this is something new I see now. Okay, so we have this one here, and this one here, and this one here, and this. Here we have one here and one here, and we have this point, and we have this point, and we have this point, and we have this point. So he said, okay, here we have 1 ampere and 2 ampere. How we find 3 ampere? Here, what you call them? I mean, I will check now. I think I have a book of this of physics too. So I will. What is this now? Yeah. 26, 790, 790. Where is it? 790 here. Yeah, here what we call it, the junction rule. Okay. direction of currents. Yeah, that one. I didn't I didn't know it actually, so I will try to understand. We can use this convention because in most situations the assumed motion of positive charge carries in one direction has the same effect as the actual motion of negative charge carries in the opposite direction. When the effect is not the same, we should drop the convention and scrap the actual motion. So the figure here shows a portion of circuit. What are the magnitude and direction of the current I? So we have all these I's, but we have to find this I. So and actually that what is make me confused because how can we find? I mean, we have this ampere, so we have 1 ampere here, 2 ampere. So this one should be what? I don't know actually. Okay, 3 ampere, 2 ampere, add them up. Here it must be, let me check if I can understand this. I don't know why it's trying to don't distribute. Because we have this one, right? I'm gonna, okay, so this is here, and this one going on. So this, it has to be, I don't know if I am right or not. It has to be 5 ampere. If you said that the inner will for out, so 2 plus 3 equal to 5. But here it will be negative. Or, oh right, it has to be right because here 5 equal 5 and 5 minus 5 equal to 0. So it is right, I think. For this one, I don't know because you have 2 ampere here and 1 ampere. That means this 1 ampere, I don't know. If you have 2 ampere here, so this is how much it will be, and this is, I don't know actually. I'm trying to see here if we have any. I don't know how we move to the next chapter here. I will check here. Where is it? Yeah, here. It is open. Okay, fine now. I don't know why every time I make screenshot, it is auto saved in my PC. Okay. And explain this structure. Structure. You know, it's been okay. I am trying to see if I have anything that related to that. is okay. So it is from chapter, or I will see here what is the okay. We'll check the current resistance and intermotive force. Not here. I will check if someone is explaining. Chapter 25 here. Same thing, but I will see if someone else make them. I see if he explained what we are confusing with.
ClickUp AI Note Taker is different.
Here, and I don't know if we have this. I will see this one. I
Than
think
all the rest. It allows you to focus on your meetings, not your notes. It captures everything, from action items.
In this video, we're going to go over a few basic equations and work on some practice problems involving electric current and Ohm's law. So one
Sorry for this.
in this video has more resistance. Now, why is that the case? Well, as you increase the length of a wire, the resistance will increase. If you look at the formula, notice that L is on the top of the numerator.
BL over BL over 8. Does we take it? Because I didn't remember if we take it or not. B over, yeah, we take it. So I will watch this video and I will see and this one. Okay.
Whenever you increase the numerator of a fraction, the entire value of the fraction increases. So as you increase the length of a wire, the resistance of that wire will increase. Now here's another question for you. Which wire has more resistance? A thin wire or a thick wire? And let's say they have the same length.
I think the thin one, because the thin one will be, I mean, if you take the area of it, it will be less than this one. So it will be this one, I think. But if you compare two objects with for length, I think the same length but different area.
Which one has more resistance? It turns out that the thin wire has more resistance
Yeah,
than the thick wire.
yeah.
Looking at the equation, the area is on the bottom. As you increase the cross-sectional area of a wire, the denominator isn't more conductor in a thin wire. But in a thick wire, imagine it as a 7-lane highway. More resistance will increase. What is that? 10 to the minus 8. They're very good conductors. In the case of a good conductor, like a metal, the resistivity is in the range of 10 to the minus 8. It's pretty low. Metals have low resistance, which means that they're very good conductors. Two good conductors are silver and copper. Silver has a resistivity of 1.59 times 10 to the negative 8, and copper is about 1.68 times 10 to the negative 8. Based on this, which of these two metals is a better conductor, silver or copper, given the resistivity values? Now, copper has a higher resistivity than silver, so therefore copper has more resistance. So if copper has more resistance, then it's going to conduct electricity a little bit less efficient than silver. So resistivity and conductivity, they're inversely related. Because copper has a higher resistivity, it's less conductive. And because silver has a lower resistivity, it's more conductive. So silver is a better conductor than copper. So materials with low resistivity means that they're good electrical conductors. Metals typically have a resistivity in this order, 10 to the negative 8. Semiconductors, or semi-metals, like carbon graphite, germanium, and silicon, the resistivity is much higher. In the case of carbon graphite, it's about anywhere between 3 to 60 times 10 to the minus 5. So it's much higher than a typical metal, but it still conducts electricity fairly decently. It makes good resistors. Germanium is on the order of 10 to the minus 3. Silicon, anywhere from 10 to the minus 1 to 10 to the 1. So silicon is not a good conductor for the most part. It conducts a small amount of electricity. And then you have insulators, which for the most part do not conduct electricity. So glass has a resistivity that's very high, 10 to the 9 to 10 to the 12. That's a lot higher than silicon. So for the most part, insulators, they just don't conduct electricity. Semiconductors, they conduct a small amount of electricity. And metals, because they have such low resistivity values, they're very good conductors of electricity. Now, resistivity is a function of temperature. There's an equation that you need to know, and here it is. PT is equal to PO times 1 plus alpha T minus TO. So this means that the resistivity of a metal is affected by the temperature. Now, the situation is different for semiconductors. For metals, as you increase the temperature of the metal, the resistivity decreases. I mean, it increases. I take that back, not decreases. It increases. Now, why is that the case? Well, whenever you raise the temperature of the metal, the free moving electrons, they're colliding much more frequently. And so the drift velocity of the electrons caused by an electric current is much less because you have to go against all the random collisions that are occurring inside a metal. And as a result, metals, they have a much higher resistance at higher temperatures than at low temperatures. So metals conduct electricity better at low temperatures rather than at high temperatures. If you cool a metal enough, like to a very, very cold temperature, a metal can become a superconductor, where there's virtually almost no resistance. So make sure you understand this. For metals, as you increase the temperature, if you can go to your physics textbook and look at, as you increase the temperature, they become more conductive. They conduct electricity better, and their resistivity decreases. So it's different for semiconductors. Just keep that in mind. Metals, they have a positive temperature coefficient. So alpha is positive. That's the temperature coefficient of resistivity. And because alpha is positive for metals, resistance at one temperature, and if we can measure the resistance at a new temperature, then using
Okay, here you solved a question. Okay. I have a question. What is the resistance of the wire? So you give us the L and the radius.
per wire has a
Let's
cross-sectional radius of 3
see.
millimeters. What is the resistance of the wire? And we're given the resistivity, which is 1.68 times 10 to the minus 8 at 20 degrees Celsius. And we also have the temperature coefficient,
So you
which
have
is
alpha and beta,
0.0068.
and we have
The equation
also
that we need is this one, R is equal to P
T.
times L divided by A. Now let's draw a picture. So let's say this is the wire, and L represents the length of the wire. And here is the radius of the cross-sectional circle that we see here. And the area of that is pi r squared. So plugging everything into the formula, big R, which is the resistance, is equal to the resistivity, and that's 1.68 times 10 to the minus 8, multiplied by the length of the wire, which is 15 meters, divided by the cross-sectional area, which is pi times the radius squared. Now the radius is 3 millimeters, and you need to convert that to meters. To convert millimeters to meters, you can divide by 1,000, you can move the decimal point 3 units to the left, or you can simply write 3 times 10 to the minus 3. Just add 10 to the negative 3 for millimeters, because milli represents 10 to the minus 3. And don't forget to square it.
Yeah, and here is so because here we have to find the area of the circle, so it will be pi r squared, and we have L which is 15. So we have B also, and B L over A, which is B over L, which is what? Which is the R. So R equal B L over A. And as we said here, so this, it will be what? A equal pi, or B L over A, right? Here the area, it will be what? Pi R squared times D. Okay, pi R squared times, pi R squared, sorry, pi R square, and this is not correct. This is just, okay.
So you should get 0.008913 ohms. If you're having issues getting this answer, make sure you put this in parentheses. Otherwise, your calculator might divide by pi and then multiply by 3 times 10 to the minus 3 squared. Part B, what is the resistance at 50 degrees Celsius? Now what equation can we use to find a new resistance at a higher temperature? We can use this equation. R is equal to the original R value, multiplied by 1 plus alpha times T minus T naught, or the original temperature. So the resistance at 20 is 0.008913. Alpha, the temperature coefficient of resistivity, that's 0.0068.
Yeah.
That was given to us in the problem. T is a new temperature, that's 50. TO, the original temperature, which corresponds to this resistance, is 20. So what you want to do in order to get the answer, first subtract 50 and 20.
So you notice that he find R naught, right? R naught. And you will find the resistance
30,
the way.
and then multiply 30 by
And
0.006.
then you will find the resistance at 50C, 50 series. So this is for B, I think. Yeah, so the resistance, which is this one, and at 50 series, so it will be like this.
You should get 0.20 from this.
So
Anytime the temperature goes up, the resistivity of a metal will go up, so the resistance will increase. And that's what we see here. 0.01 is higher than
it is because T, the temperature of is proportional to the R.
0.0089. So as the temperature went up, the resistance of the copper metal went up as well. Now let's move on to part C.
So part C now, okay, so you change, we have A ampere, and we want the voltage drop of the line.
So that's going to be 0.2 amps. And resistance at 20.
So why use Grammarly over ChatGPT? Well, Grammarly.
I actually want to, I will change it. I will move to Brave because Brave is much better. No ads, no ridiculous thing. So yeah. We move, we are right here, right?
By 0.00.
Yeah.
So the voltage drop is 0.0017826 volts.
And we already have the R. R for the first one, right? I think first one. Yeah, first one.
Well, let's convert it to millivolts. Let's multiply by 1,000. So this is about 1.783 millivolts. Now what about part D? What is the voltage drop per meter? So we need to divide this by 15.
If the voltage drop per meter at 20C, if you want, okay, right per 15, I don't know why. Let us see.
8913. So the voltage drop is 0.0017826 volts. So this is the voltage drop per 15 meters.
Yeah, because you said here 15 meters.
Because that's the length of the wire.
Yeah.
And because the number is so small, let's convert it to millivolts. Let's multiply by 1,000. So this is about 1.783 millivolts. Now what about part D? What is the voltage drop per meter? So we need to divide this by 15. And you should get 0.119 millivolts per meter. With this information, we can calculate the voltage drop at any length. So let's say if the copper wire was 300 meters long. All we need to do at this point is multiply it by 300 meters.
If he asks about the voltage drop per 300 meters.
And so these units will cancel, and it's going to be 0.119. Now this is a rounded answer times 300. So the voltage drop is going to be 35.7 millivolts given a length of 300 meters. So that's it for this problem.
Yes.
Number 2. So the voltage drop is going to be 35.7 millivolts given a length of 300 meters. So that's it for this problem. 100 meters
I don't get it.
length. So let's say if the copper wire was 300 meters long. All we need to do,
Okay, if the wire was 300 millimeter, 300 meter long, so we have to multiply 0.119 by 300, so we can find the voltage when the copper will be 30 meter long. Okay, and this
the
is
same wire conducts a current of 0.41 amps. Is the new temperature higher or lower than 20? Well, the current decreased as the temperature changed, which means the copper wire is less conductive, and so its resistance is greater. The resistance of
here what's happening is we have
metals conducts a current of 0.41 amps. Is the new temperature higher or lower than 20? Well, the current decreased as the temperature changed, which means the copper wire is less conductive, and so its resistance is greater. The resistance of metals will only increase if the temperature increases. So therefore, the new temperature is higher than 20 degrees Celsius. Now let's go ahead and calculate it. So first, we need to calculate the resistance at these two different temperatures. So at 20 degrees Celsius, we can use the equation V is equal to IR,
yeah
where R is basically V divided by I.
12 over
So the voltage is 12 volts. So 12 divided by 0.45 will give us an R value of 26.667 ohms. Now let's calculate the R value at a new temperature. So the
which is
voltage is still
R0.
12, but the new current is 0.41. 12 divided by 0.41 is 29.268. So that's the resistance at the new temperature. The equation that
Which the R0 is referring to the old one, and the new one will be 0.41 ampere, so you have to find the
we
resistance,
can use to find the new temperature
which
is
is
this
R0,
equation.
alpha T minus T naught.
So the new R value is 29.
Yeah.
Value is point. We're looking for the new temperature T.
And we're looking for the new temperature, and we already have the order, which is
The
20.
original temperature. First thing we should 7 here. Divide both sides by 26.
Yeah, so here how we can find T manually without using the calculator. So first we have to divide it by 26,
0.667.
and after that,
If we do that, we can get rid of the brackets that we have here.
yeah, actually, it's right.
So 29.268 divided by 26.667. That's next 0.09.
Yeah. So here we cannot say that 1 plus 0.0068 is equal, for example, 1.0068, because 0.0068 is is connected with this array, with this arrow, which is t minus 20. So we just take one the other side, and we end up with 0.0068 times t minus 20. And then we can I don't know how we can divide it, and we can divide
0.34.
and
And that's
write
equal to T minus 20. It's late T.
minus 20 the other
So the
side.
new temperature is 20 plus 14.34. So it's 34.34. And that In this video, we're going to talk about how to calculate the internal resistance of a battery, as well as the battery's terminal voltage. So let's draw a circuit. It's very, very small. Now, let's see what happens if we decrease the resistance. If we connect a battery to a device that has a... So what exactly is conventional current? Well, let's talk about it. In this video, we're going to unit seconds. Now, you need to know the charge of a single... In this video, I'm going to...
Okay, for these videos, I will watch it all because we have first 1 to 7 and I will watch it after I finish this. So first we have to start here. So here I don't know what is this. I will see if I have any. Okay.
In this video,
In branch beam, I think yeah, in branch beam. That's this we have to check out the branch curve. Here there is yeah, I will say this one.
This lesson we are going to learn how to find the branch current. For branch has resistor R1 in parallel with R2.
Circuit diagram. I see now. Okay. Circuit diagram. Problem. Which is I think here. No. I will see it later. So I will skip it for now and I will return it because I don't know how we find that I equal 8 am. I mean 8 ampere. I don't know how because okay, so let us see. Okay, yeah, so okay. So you find that this is 5 ampere. Is it right? Okay, right. So you find that to be ampere. Okay. Okay, so this is will be okay ampere. Here he said it will be 3 because it will okay. So here it will be 3 ampere and it will be divided to here 2 and 1. So this is I think because this is 5 and 3, the rest of 3 will be 2, right? Yeah, it will be 2. So this is 2 ampere. This is 4 is going in and we have 3. So this is have to be like this. Yeah, because it is impossible to that two arrows that's going in, and the other one will be in the point. It has to be out, so this is have to be out like this. So this is it will be this one, but I don't know it will be what. So here 3, and we have 4, and we have here 2. I don't know how you find back 6, 6, 3. Yeah, okay, this is 2. I'm sorry. So this will go in this, and this will go in. So we have 6 ampere, and so this is will be 6, and this is 2, and this is going here. Then here. So this is will not go at this one. I mean, it will not go in the point, it will be out the point, so it will be at this. So it will be the sum of 6 and 2, which is 8. I will solve it again. It's easy. I think it was hard. I don't know, because when I was in the lecture, the professor was solve it, and he was talking so much. So I I feel that I felt it will be harder to understand. So we have here 1 ampere, and this is going up. We have here 2 ampere, and it's going far away. So this one, it has to be in, because the third one will be the opposite of the 2. If 2 are going in, the third one will be out. If 2 are going out the point, the third one must going in the point, or into the point. And so it will be 3, because it will divide into 2 and 1. So it will be 3. And this 2, we have 3, so it will be the sum, it will be 5. 5, and okay. So 5 will be 3 and what? And 2. We have 4 here, and we have 2, so it will be what? 6. We have here minus 2, okay, so here 2 are going into, the third will be out, so it will be 8. The sum of 2 and 6. Okay. Here example. So as I said, the n and the r. So here I know plus I3 plus I1 equal to 0. Current density, which is J, is the current per unit of area defined. Okay. Delta Q equal NE, and J, which is the current density, equal to Q of the volume. Here we have this problem. So I will pause now. I will go to the bathroom, and I will return. I will come back within 5 minutes. Okay. So, yeah. So the current in cylindrical wire of radius r is equal to 20 meter. 20 millimeter is uniform across section of the wire and is J. Okay, what's the current through the outer portion of the wire between what? Radial distance r over 2 and r. So it will be integration j dot dt, and j is a constant, and we have okay, current and the distance from r over t to r. Okay, a outer equal. I will skip this because it's my first time I saw this one, so I will skip it. But also, yeah, this one. The okay, resistance, resistance and resistivity. So the so R equal VI, and this I want to be ohm for V volt and A, and I mean I to be ampere, and the resistivity is defined B E over J, and we can write it as R equal B times L over A, and A is proportional with L, and it is I mean and R is inverse with A, which is if we have uh, big area, the more value of area, the less resistivity of this object of or this material. And yeah, and this is for the R depends on the temperature. Okay, where B naught is the resistivity as 20. Oh, so it is a constant here. Okay, so that 20C or 20 series is constant at T alpha is the temperature coefficient and T as Kelvin. Let's see here. Sigma equal 1 over B. Okay. Yeah. I will solve this one. Is I turn it off. I don't know why it's happening. Okay. What's happening? Okay. Here we have this one, and we have to choose. Okay, so this one. So this is the normal things. We have R. So we have to rank them according to the current through them. The current? You mean I? I don't know because we have this one, okay? And I is equal to V over R. So let us say that V is a constant. So R for the first one will be L over N. So it's the same thing here. Okay, we don't have anything. Okay. Second one, we will have 1.5. So 1.5 over 1 over 2a. And this will be 1 over 2. It will be 3. So we have 3r. So here 3r. And if you have 3r, this will be reduced to 3i. That means we have less current. For the third one, it will be half L and half L. It will be moved, right? It will be same as first one, I think. So it will be V over R. So it will be, yeah, it will be. So I think it will be A equal C and less than B. I think that. I don't know. Okay, so here replace R with BL. يعني actually you can find R and replace the area. Okay, we end up with something different. Okay, he said first one will be A over L. That's correct. Second one will be 2 over what? By 2. Second one will be, I mean, how we find the second one? Length is 0, what? No, this is 1 over 2. Okay, there's something wrong here because for me it will be 2.3. Why? Oh my god. So use this one, right? So here place R to be B over A. So it will, oh, I see now. Yeah, I will tell him that B length is not L. It is 0.5, and also area, it is not 2A, it is 0.5. So it is 0.5 because they are the same, A and A and B, or A and C, I mean. Yeah. Bro, I told you 0.5. That's it. Okay. This is not, yeah. I mean, this is 0. Okay, I have right 0.5. A. Please stop. Okay. Yeah, exactly. My God, I don't know why he changed himself. Itself. I don't know if it's A or so. He changed everything. I don't know why he changed the third one. Here it will be 2, I think, right? 0.5. 0.5. A. Yeah. It has to be AC, same thing. That's the same. I don't know what's happening right now because when I when I take a screenshot of the question and I see it in Deep or ChatGPT, they are like rewrite it as they want. Some variable they change it, some numbers they change them. So I don't know why they play with them. I just need from you to solve the question without rewrite or make any change. I don't know why it's happening all the time. So anyway, A and B. Okay, I have to see now. So this will be same thing. B is same thing. Why? Zero what? Okay, okay, it's fine. It's fine. Third, okay. So you mixed up. So you write B as C and C as a B. But our solution is true. Okay, this is true, but he play with number again. I don't know what is the problem. So and here, okay, so we have this one. So here he gave all the dimensions. To find our Ohm's law R equal VI. The slope will be slope is like that because VI uh, V over I, which is R. The diode is non-ohmic. Yeah, because here we have I over V, which is 1 over R. And the slope will be it will be like this one. Ohm's law, yeah. But I don't know how okay, why you flip it like this? Ohmic material, okay. And this non-ohmic material, okay. Electric power is the energy, and this is what? We take vi and ri square. We have v square over r. Come on, he's writing a big question. Yeah, there are and what and but you want the r, okay. And we want the r when it has r over 72 over 2, and you have to find p when it will be when r uh, when r is 36 ohm. Here you write the summary. Uh, the current is I equal dq over dt, so it's the derivative. If we have the q or yeah, okay, if we have the dq equal I dt or dt equal yeah, so it will be integration. Resistance of the conductor. Resistance R equal VI. So okay, same thing. We have R here. We have B. Okay, here B. So B equal B naught and alpha. I think yeah, okay, so okay. So B minus B naught equal B naught alpha T minus T naught. I think T naught always be 20, I think. It's lagging. Yeah, we have a stop here. So this is for um, so this is when we have 1 over r. So this K on the potential difference. He said that so this is for the atomic material. This is a non-atomic material, and or semiconductor. He said. Um, and, okay, so that is one that doesn't obey Ohm's law because its resistance changes depending on the applied voltage. Yeah, you said semiconductor or for example for a conductor. And semiconductor is something that is not conductor, but at the same time it's conductor. We can say it is like conductor, but in the low level. At, yeah, I mean, semiconductor. Conductor are material with electroconductivity conductor and insulator. Yeah, as I said, it is between conductors and insulator. Yeah. Yeah, and we have resistance depending on the temperature, which is B equal B naught 1 plus alpha, and this will be T minus T naught. So this is be T, and yeah. So if he told you that where B naught is directed at, I think 20, I don't know. Ohm's law, a given device conductor resistor. Obey Ohm's law. What is a Ohm, Ohm's law? I don't know what's Ohm's. What that mean? Ohmic material. Here I told him is semiconductor are. Here I was talking about non-ohmic, right? So ohmic is also. All ohmic material are conductor, but not all conductors are perfectly ohmic. Yeah. Bar, we have VIV or we have uh, V square over R and uh, I square over and IV and I square R. Here for yeah, resistivity of a meter. Yeah. Here chapter 27. Simplest circuit resistance. So resistance R connected to a power supply. Battery has a voltage and yes, so this is the rule here. If loop is going from positive, so it is be positive. If it is going downside in the opposite direction of the normal direction, it will be negative B. So negative B. So negative B, here positive B. and if the loop is going the same direction of I, it will be negative I, which we have negative B. And if the direction of the loop is going in the opposite direction of the current, it will be positive I R and positive I and positive B. Here we have the rules that it's the same thing for a battery, yeah, same thing. And also for the resistance, same thing. Ideal battery has no internal resistor. Real battery has one internal resistor. Example, a real battery connected to a resistance R. So, this loop it is going clock or counter or clockwise, and if I is going same direction, it will be minus IR and minus IR capital, and for E it will be positive because it is moving from positive to negative, and yeah. Resistance and series. So in series we said that R equivalent is R1 plus R2. In parallel it will be R1 plus R2. This for series, this for parallel. This for example, so loop are going clockwise and also for the current. So start from positive, so it will be positive B minus RY1 minus IR2, and here we have same I because in series we have same I, and yeah, and for the parallel uh, it will be the same. Yeah, for this one it will be here positive E minus ER, and R equivalent, as we said, it is for series R1 plus R2. Okay, single loop circuit with two real batteries. We have E1, E2, R1, R2, and R capital. What is the current I in the circuit? So, first, I don't think that there is a question that will ask you about something without a drawing. I mean, he will draw to you and he will ask you about the unknown variable. And I don't think that we have to draw it. Yeah. What is the current I in the circuit? So the loop is not always moving clockwise. Actually, you can assume the direction of it and also the direction of I. I will choose the opposite of the solution. So I will go correct this counterclockwise, and for I will choose it to be the opposite direction of this. So to be like this. So I will be like this. So it will be like this. Yeah. So that means we have E. I will draw it. Okay, move it on, move it. It's coming like this. So this is positive, and uh, and this is negative. And for R1, it will be 1 I, and this it will be down. No, it will be in the opposite direction. It will be positive and positive R2I. And we have R here. So it will be also going. So this will be going like this, and this like this. So it will be positive, so it will be like this. So it will be negative and minus and 2, and we have here I, R1, and R, here R small. So we can write the common R1 plus R2 plus R, we have here same I, so I, we have E2 plus, okay, I think there is a way to make sure that your solution is true, is to change the sign of each of them. If it um, if this equation after changing the sign the opposite, so it will be right. So if we change to be E1 minus E2 minus R, and so it's the same thing here. That means our solution is true. And we can I mean write here anything. For example, here it will be what? R1 plus R2 plus R. Let me see now. So here 40 minus 4.4 minus or plus 2.1 over 2.3 plus 1.3 plus 5.5. So it is negative 0.2. I don't know why. Same thing, but direction. Yeah, because if we so we have this here with the right. Yeah. So if we flip this on the other side, it will be negative. This is all negative. So yeah, same result. So here just be sure that after you find this, it is equal to 0, and after we yes, and like this, um, we negative e1 plus e2 over the negative r1 plus r2 plus r. Yeah, it will be the same thing. So the assumption of, of the direction of loop and direction of y is depending on you. So you can assume anything, not necessary that the direction of loop must be the same direction of y. You can take the opposite direction of m of I and the opposite direction of to take the direction of loop um, um, in the opposite direction of I. It is the same thing if you take both of them in the same direction, because you will end up with the same result as shown here. So we will move to the B. What is the potential difference between the terminal of battery 1? Yeah, so okay, multi-loop circuit. So here we have a series 1 and so it will be with circuit like this, and those for I, and so it will be negative, I think. Um, Okay, I will skip this. I don't understand this. Okay, here multi-loop circuits with more than one loop. Yes, I'm sorry. So circuits with more than loop will be like this. So we end up with actually three loop because we have this one loop. We have loop 2, loop 1. Resistance in parallel, and we said that will be I will be the sum of I1 and I2. And R equivalent it will be 1 over R1 plus 1 over R2 as this one. And yeah, for series it will be R equivalent it will be R1 plus R2, and for I it will be same. In general, resistance can be not parallel, not series. Two loop circuit. How to analyze multi-loop circuit. Choose direction for currents, as I said. You can choose anything you want, and also you have to choose direction for loop as he mentioned here. Choose directions for center, for currents. Yeah. Figure out how many independent current. And as I said, here you can you can take this point and find the search rule for the junction rule, or I think they call it junction rule, or what? Yeah, for the junction rule for the current. So here it will be minus I1 minus I3 plus I2. Yeah, so I2 will be I1 plus I3 as it's shown here. A right loop equation, yeah, so you write this loop equation and you will find that you will take I2. So here you will replace I2 with I1 plus I3. So solve to find I1 and I3 as we mentioned before. Here we have sample problem 27.02. Resistors in parallel and in series shows a multi-loop circuit containing one ideal battery and four resistances with the following values. Here we have R1, R2, E, and R3, and we have R1. So what is the current through the battery? So here, so let us write it and see what's happening. I'll take a screenshot to save my time. So here what's the current through that battery? So you can find this by using the Kirchhoff rule actually. I mean, take the equation maybe, or Roman that we have already, or the R and E, and we can find it as we mentioned. It is, or let us break it here. So it will be like we have R1 and R2 here and R4 here, and we have this one, and R2 will be like this. So this one, yeah. So this one in parallel, and this in series. This one, which is R2 and R3. So you have to find them. It will be what 12, and we end up with this one. So this is 12 ohm, and this what I'm what 20 and 8. You can find them by adding them 20, 38. He actually okay. He just find R2 and R3, and yeah, and you didn't have to find the R equivalent. So so we have to find this loop. If we assume this is I, and the loop is going clockwise. So we end up with this. So it's going here, going here, and going here. So it will be a positive I times 20. Um, um, and also all of them, it will be, uh, yeah, okay, right? Yes, sir, right. So, um, I'll check now if, I actually can take I as common factor. So I will take I as a common factor. 12 equals 0. To be, okay, I don't know why it is negative. I will check now. So we assume that I is going, and um, let me check. It will be positive, right? But here is the negative, positive, and positive, positive. So start from here, mean positive in, and it will be like this. Okay, so it will be counterclockwise. It has to be. It has to be positive. Actually, I, I, um, I feel the same direction of the loop that he did, but I changed the direction of mine. And there's something weird. It has to be. I will check now. I hope this mistake happened. I don't know what's happening right now. Yeah, it can't be negative 0. I don't know. I know that I can. Okay, here's the question. Can I take the same direction for the individual loop, or just I can take whatever I want if I have multiple loop? Okay, I will take the opposite direction, so it will be negative, right? And if I take the, okay, I will just flip this one, and this way we have this. So a negative e and same line, right? It will be all negative. Okay, so this is negative, 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 and we have this is negative. So it has to be again negative 0.5. I don't know what's happening. So this will be negative and this will be negative, right? Equal I divided by R plus R2 plus R3, but you have this one. I will ask. Should we, when analyzing a single individual circuit using Kirchhoff, the direction you assign to the loop and voltage drop across resistance must be consistent to be ensure correct calculation. And yeah, choose clockwise. Here I think, yeah, so here from the question he assumed or he given to us the direction of I, if I didn't notice. So it will be E, we have a negative here. Yeah, we can freely choose the direction of loop traversal and the current flow. Yeah, so it's fine. But here, because the question says he already assumed that direction of I, and that's why we messed up, and that actually make me confused. Okay, I think I will stop right now. I don't know. Okay. I will come back within 5 minutes, or I will stop for half an hour, and I will see. Okay, we are back now. Yeah, so we, we will stop here. What is the current as R2 through resistance R2? So he's asking about this one. So we can take this loop and find it. So it will be this one positive. Here minus R1, I1 minus R2, I2 minus R4, I4. But actually, I have here for R4 and R1 series, so we can take the common factor 1 minus R4, or you can make like this and be this R2 I2. We have here E, and you can find ammeter and voltmeter. We have to know that so I just testing the microphone to be sure that my voice is clear. Okay. So ammeter is a device to measure the current I, and the voltmeter is to measure the voltage. To measure the current, we insert a meter between the wire and so here. For voltmeter, we put it between we put it in parallel to measure the voltage. RC circuit is a resistance R and capacitor in series. And I want to ask about that. What is RC circuit? What's happening? RC that contain both resistor and capacitor. These components interact to reduce time to competitive behavior, making RC circuits fundamental in electronics for application like filtering, timing. RC. Actually, we did not take this one, so I will skip it for now. Okay. So we have capacitor and resistor at the same time. So at time t0, the capacitor is not charged because because he did not, because the switch is open. When we close the switch, it will start charging, and and if we want the value, it will be positive E minus Ri minus AC because here is the point. Here we have positive and negative. It will cross and it will travel from positive to negative. But here the loop it will travel in the opposite direction. It will be minus Yeah, so okay, we define time constant. What in the French? That's not important. We just know this. The solution of the equation is Q. I don't know. Oh my god. I forget that RC is not included. It was RC is not included, so this one is not included, right? And also this one. So this is the summary. We will not take this. Yeah, and also this. And uh, I was actually I didn't know that. That's fine. It's fine. Because it's not included. This summary that equal the okay. And this one circuit containing 6 resistor is connected to this one. Okay, so we have this. So you want what is the equivalent resistance. So here series and here series. So first find the series here and other series here. After that we end up with a parallel. So find the parallel. After that, yeah, I mean, let's call this 1, 2, 3, and 4. Here 5 and here 6. So R1, 2 to be in series, and R3, 4 in series. So it will be like this one, like this, and yeah, like here resistor 5 and here resistor 6. And after you find this parallel, you end up with this one, which is in series. So yeah, so here you will find this one, 14 plus 20, 16, 70 plus 20, 90, and find the parallel of it. So it will be like this one. And this is in series, so 50 plus 20 plus 36. It will be 106. And he's asking about the charge flows through the power supply. And he mentioned the time, which is 2.5 minutes. So we have to to convert minute into second by from big to small. It will, I mean, 2.5 times 60 will be 150, and 150 we will so the charge is Q over it was Q I T I the T, yeah. So we don't have I, we have to find it. So I is equal in volt. We already have 120 volt, and yeah. So I equal V over R. R equivalent, which is 106 and 120, so we have 1.30. After that we find Q, which is 1.30, and 2.5 times 60, we end up with 169.5. Here he asks about the potential point on point B and A and B. So in point A and B, if he asking about A and B, I mean, yeah. So he asked about this one. So this is what the voltage will have. So we write 36 of the because this will be 36, right? So, for example, here we have this. So this one and this two, this one and this two. So you have B and A. You want the voltage of this area. So the voltage will be R equivalent times I. And I here that we find it, I think. No, I here it will be, yeah, it will be that the I that we find it. So I will be 100. Sorry for that. Yeah, so yeah, so 1.30 for I for equivalent 106. No, R equivalent for this area, which is 60, 36, and you found it. For D, we ask about the bar dissipated between A and B, that means B. So we have, I think, I don't know, I V square, or I square R, okay, I square R, and I square here, and R equivalent, right? I mean 36, yeah. But the question here we have, mm, so here we have the question 3, we have this this circuit uh, and in parallel. I think he wants from us to find the equivalent. I don't know because he didn't mention anything right now. Our equivalent, okay. I'm gonna solve it in my or let's take screenshots. Okay, so we will start from the right side. All these actually, yeah, all these in series. I think they are in series. Yeah, they are in series, but four is not in series, right? Oh, yeah. It is in series also. So 2 plus this, yeah. So this one and this, yeah. And for this one, 2. So we insert with this one. This one will be 2 plus 2 plus 2, 4, 8, 12. And we can find this as parallel, right? Yeah, so 12, 5, and 1 over 6 plus 1 over 2 will be 4. So we will delete this and write here 4 or 4 ohm. For these series and these in series, so we end up with this. So this we have this one, and we have one here, and we have one here, and you have the following. So this and this will be in series, which means it will be 4, must be 4 actually. Yeah, okay, 1 minute. Okay, this is 6, this is 4, and this is 2, 2, same thing here. But how we, I think he adds something, because, yeah, he adds something here. I don't know why. Maybe he messed up here. I think he messed up. So this is we in series and this one we in series. So we inside both here 4, 4, 4, and we have 2, 2, 6. Now we can take these as a parallel and I think we can make this as a series. So these in series in parallel or in series. I mean, yeah, in series. So it will be the one, and this is one, and this one. Yeah. So this will be 12, 6, 2, 2, and this in parallel. So it will be 12 and 6, also 4. So we end up with this 2, 4, 2 in series. So it will be 8. And yeah, so we are right. So for instance, we just, so these are in series, all of them are in series. And he ends up with this. This one and this one are in parallel, so we ends up with 4. 4, these are in series all, so it will be 4. And no, it will be 12, and you will take 6 with 12 as a parallel, so it will be 8, 4, and we will take all these in series, so it will be 8. It's simple, but just you have to know where is the series and where is the parallel. Here we have question. Maybe yeah, we have this one and this one and this one. Let me zoom it in. So this one, the current through 5 ohm resistor. What is the current through 5? 5 ohm at junction, and he gave it to us the junction, which is I1 minus I3 minus I2, which is I1 equal I2 plus I3. He is asking about, actually I will solve it now, and I will yes, I will solve it now on my iPad, and I will write the solution here. I will copy my solution and let me write it here now. Okay. Okay, so here we have this one. So we have point B, and we have a resistance here, and we have this one, and yeah, we have this point, which is A, point A, and here we have 2 voltage, and second one, and this resistor. We have this resistor, and we have tools on the right side. So this is 2 ohm, 5 ohm, and 3 ohm, and this is 8 volt, 8 volt, 3 volt, 10 ohm, and 10 ohm, 5 volt, 10 ohm, and 5 volt. So we can take this loop for loop, and for I will take in counterclockwise. So I will take counterclockwise. So it will be direction, and it's also in this direction. So it's flow like this way. So here he will ask about I1, and he will ask about I2, and he will ask about he asking here the current from 5 ohm and 5 ohm. So yeah, here actually I have to take loop 1 and loop 2. So the loop 1 will be, so this loop 1, this is loop 2. Loop 1 will be positive if 5, I mean, minus minus what? So here he take the opposite. Okay, I will solve it myself and I will show my work here. So here to be for the loop 2, it will be from my own solution. My loop is traveling counterclockwise, 3 positive minus 8. So you will notice that in loop 2 we have 2 and 5 and 3 in the same I, which is basically 3. I3, I3. Here you have to call everything. Here you have I3, and this is I1, and this is I2. And we have the junction rule. It will be I2, I1 minus I2 minus I3, I1 minus I2 minus I3. And will we can replace I1? Yeah, I will replace I1 equal I2 plus I3. And I will replace this in the first one. So this is 1, and this is 3. I will check on my calculator to be, to be sure that I'm not messed up or mixed up anything. Minus 20, possibly 0, 0, minus 20, minus 10, 10, 0, minus, minus 10, minus 10, minus 1. This one will be 1 minus 1 minus 1, 0. Yeah, my solution is right. So I1 here it will be what? I didn't change anything. Yeah, it will be half. Let's go. I1 is 0.5 am. What am? I mean 0.5. Okay, negative 1.5. And I3 is 2. I hope my solution is work. I hope. So here, this is right. But not right. No, no. No, it's happening right. So my solution is right because I1 equal I2 plus I3. So minus plus 2 it will be half. But here he didn't mention that. He mentioned that I3 will be 0. I don't know how. So here he said that I1. Fine. Okay, I1. Confusing. I2 half. How? Why would I don't I don't trust his solution, so I will see. So in my solution, I3 must be equal to can you find I1, I2, I3? Yeah, I1, I2, I3. It's not working. What's happening? I would open another one. It's not working. And also here, so much okay. It's not working. Even I am entering with my second account. No text extracted. What's happening? I will ChatGPT. I think my I think okay, I can. Okay. Can you find I1, I2, I3, I3? I hope my solution is right because I didn't have any time to. I didn't. I didn't want to waste my time in this thing. Okay. What? Bro, there's something wrong. I have to solve it again. I'm trying to, I will try to solve it again. Here he said that I be zero. If I2 is hard, yes, it's correct, but I don't know. I don't know actually. Maybe he's not true. Maybe I don't know. Because here I can't tell my solution is true because it has to be like it has to be like I2 equal hard, but I I I I found it as minus 1.5. Maybe I have to follow that direction that he made. Maybe I don't know, but I'm not I'm not following with him because I want to show to myself that even if I take the opposite direction to be right. But here I will try for him. I will try the solution that he made. I wish I have a chance to share my screen, but I don't know. I can't do it. I was searching about the best thing or um, the way that I can share my screen, but I cannot. I wasted my time that time. I will be here for the I should be here. And this it will be clockwise. Okay, let's start with the loop one. For the loop one, it will be ten I minus 10i2. So it will be 5, 10, I think. Yeah, 10. What happened? So it will be 10 minus 10i1 minus 10i2 equal to 0. We take side, it will be for the junction rule, it will be this is I3, right? That's okay, this, and this is I1. I think my my fault was because I didn't consider the direction of I2, I3, I1 because when he considered it as it would be upward and right side, left side, that would affect the direction of the eye that you would choose. So if you choose that to be like this, so it has to be counter. It has to be clockwise. And here, because the I1 will be in the left side, so it has to be that direction. It has to be going counterclockwise. So 2 equal I1 minus I3, right? I will call this I2, it's fine. For the second loop, it will be what? And for I2, it will be plus 3 minus 8 equal to 0, right? So I1. So I1 it will be like what? I1 will be I2 minus I3. So 10 I2 minus I3 plus I2 equal to 10 plus 3 is 10. So 20 I2 plus 10 I3 10. So this one, and this one. I will check here outside. So it will be what? It will be negative 1, 1, negative 1, 0. Alright, I'm gonna start with 0, 10, 10, 10. So 0, 10, 10, 10, 0, 10, 10, 5, negative 1, 1, negative 0, high, high. Yes, finally I do it. Yes, it will be like this. Yeah. I solved it now. I'm gonna send the picture now. Okay, I send it now. I will. Okay. This is the picture here. I will view all photos. Copy it. Yeah, I will copy it. It's fine. I will copy it. My brother. So let's send the photo. Yeah, this is it's happening. Yeah. So this is the picture here. Okay, the thing, the thing is, if you take the direction of, or if you consider the whether the I1, I2, I3 will be into the point or outside the point, so this is would affect the direction of the current. If you, yeah, so if you consider that I3 and I2 will be like this, and I2 will be into the point and this will be outside, that means the current will flow with I2 and I3, and at the same time for I2 and I1. So it will be like from the, yeah, to be counterclockwise. It will move with I2 and I1. And for loop, you can even you can take it counterclockwise or clockwise. It's fine. After that, you have to find the junction rule. So it will be I2 equal I1 plus I3, or I2 minus I1 minus I3 equal to 0. And you will find the I1. So you will replace I1 with I2 minus I3. And that is what I make. And you will find that 3 ohm, 2 ohm, 5 ohm in series. So they are in, so they are having the same current, which is I3, and this for loop 2, and we end up with 10 I3 plus 10 I2 minus 5 equal to 0. And that's why we have this one. And this is the the the, the important thing. Yeah. So this is the point. After we find so it will be for the loop 1, 20 I2 plus 10 I3 equal to 10. And for this one, after we have loop 2, it will be 10 I3 plus 10 I2 minus 5 equal to 0. This thing we don't have to write as this formula in the calculator. So we have to take minus 5 outside, so it will be 10 I3 plus 10 I2 equal 5. And this is for the second one. And for I, it will be I minus I1 plus I2 minus I3 equal to 0. This is in the calculator. We end up with I1 will be half A, and I2 half A, and I3 0A. That means there's no current flows in the 3, 2, and 5 ohms. And yeah, because he's asking about 5 ohm, so it will not be anything here. So yeah, so it will be 0. And they ask about the current I2 to be higher and I1 to be higher. What is the potential difference between A and B? A, he wants the B. So if you consider this I and this loop, so it will be 3 minus 8, uh, 3 minus 8. This is not included, right? It's included for RC. We will skip it. And this is also right. Charging capacitor, yeah. It's not included also. This is the final thing. So the current here, if you consider it to be like this, I will consider it to be like this I, and for loop to be like this. Or let's take the same loop, it will be like this. So we end up with 16 and minus 3v minus 1I, and even I forgot it, minus I 12 volt. So it will be 15 volt. 6 minus 1 minus 1 minus 2 should be 4 I equal to 0. I has to be negative here, right? Does it make sense? I wish to be again. My God, my God. Okay, so this is I, and this is the loop. It will be like this: 16, 3, 1 ohm, 1 ohm, and 12 volt. This is, yeah. Okay, I will start with 12. Okay, it's negative half. I don't know why. I'm gonna try to solve it again. I will solve it again. Uh, here, 12, negative, we're positive one, here, negative 3, and here, positive one, and here, positive one. It seems to be like this one. I don't know what's happening. Negative half. I don't know why it's happening. Very confusing. That is sometimes we mixed up, so we don't have idea about what is the outcome. So fine. I will start like this side. I will start from this side. So negative 3. Again, I don't know what's happening. Maybe 3 would be not. I don't know actually. Yeah. I will solve it as the question. So I will be like this. negative 69 minus 3 plus I minus I minus I minus I. I will see it now. Yeah, it will be 0.58. I don't know what's happening. I solved it right, but I don't know what's going on. Maybe I do. Maybe I have to follow the instruction of this one because I know that I can fairly freely choose the direction of loop and direction of y, even if they are in the opposite direction. But I don't know what's happening now. I will try to I will stop now. Yeah, I will say anything else. I think I have some. I have. I have a question, so I'm going to share it. Um, what's happening? It's not. The picture is not. Um, it's not clear anymore. So I can't see anything. E2. This is. Yeah, I think this is E2. This is E3. This is E1. This is I1. Then this is R1. And this is A. And this is B. And this is R2. And this is R3. And this is I2. And this is E2. This is R4. This is I3. So he wants the current through the resistor R. So I'm going to choose this loop. But first of all, we have to find what is the direction of R phone. So let's take this point. I will choose I. It will be like this. This is I1, and this is. I will choose this for R4. I don't know why, but I'm gonna choose it, right? So I'm gonna. But he said that R3 will be down, so it has to be like this for 3. So 4, it has to be down more. I think it will be like that. It will be like this. 4, 4, 4. I2 it will be like this. I2. I don't know if I am I'm doing right. I think no. I think it has to be with I2. So I3 must be with R4. So here R4, right? Here I3. And here I1. Here R4, I don't know if it will be downward or upward. I will choose that. No, it will be down, to be upward because it will be with the direction of I2. So this is for I4. So if I went for R1, maybe I missed up, I don't know. Okay, for this one, I will delete everything. No, I will just delete these arrows. So I will write another one. We'll just delete this here, and this one, and this one. Okay, and this, yeah. So as I see now, I1 is going like this. Yes, it's going like this for I1. So I1 to be like this. This is for I1. I3 is going downward. That means it will be moving counterclockwise. So it will be like this. This is for I3. I2 to be downward here. So this is I2. Let me call it 2. And this one is resistor 4. We didn't know actually the direction of it, but we will consider the direction of it is going with, yeah, it will be down. Yeah, right. It will be down. It will be down here. Yeah, because it is impossible to for 3 point that is coming in the point A. So 2 is going on and 1 is going out. To find, I will choose this loop 1, and here loop 2. Loop 1 will be direction with, yes. So it will be what? So it will be here have 10. So it will be 10, and for R1 it will be negative. So it will be negative R1 and I1. So I and 5, and that's for R4. R4 is 1 and I4 is, we don't know it, but it is series with I1. So it will be also I. So here 1. And we have this to be negative 2, and for R2 to be negative R2 with I2, so it will be same I, and R2 will be 4. We can do the calculator. Minus I times 5 minus I times 1 minus 2 minus x times 4 equal to 0. 0.8. It has to be 0.8. So this is for 1 and 2 and 4 because they are in series. Actually, I don't want to waste my time. I just want to be sure that my calculation is all correct. So this is not working, right? So, and R3, yeah, finally, I'm going to ask about the client. I'm going to see the first one. I hope it's correct. Okay, let's see. 0.8. Yes. Yeah, so it's 0.8. I'm going to ask him about. See, I don't have to find I4. Yeah. What? How I4 is equal to 2? What? Should be 2? And oh, I said not. So here I said that this is for loop 1, right? Okay, I want to ask why we didn't take the I4. And he also ignored the 3 here. Maybe he did not notice it, maybe. I don't know. Maybe. Because it has to be like this. It has to be. Even the picture is not clear that way. Yeah, I will continue as my solution is right. What is the potential drop on resistor R3? So R3 is here. So you want the potential drop. R3, we have R3, but we don't have I3. And that is confusing. So we have here, maybe I4 is not serious with this. I don't know. I mean, I4 is not serious with I2 and I1. But in fact, we don't have I4, so it will be, we will be in a big trouble because we are dealing with two unknowns, which is I1, I2, and I4. So if I take this loop, so I am dealing with series and also for this. So it has to be, so if I take it like this, I'm confused because even the direction of I3 is not correct. It is going here, meaning it is going counterclockwise, but we have I2 is going here. So maybe we are dealing with each of the direction. I mean what? I mean if we are going for the loop 2, if the direction of loop 2 will be counterclockwise or I'm sorry, clockwise. So we will see each of the resistor and its direction. I think I don't know. Maybe it will be like minus I2 R2. Maybe this will be I hope my sound is screwed. Yeah, it's clear. I'm sorry for that, but I'm trying to make sure my sound is clear because the previous one like I was whistling all the time. Anyway, I'm trying now to continue. So V3 and that's it. R4 and R3 will be downside. So positive I4 R4 and positive I3 R3 equal to 0. I2 we don't know I2, but I2 I3 same thing. So we consider it I3 I2, or I will consider as I R2, which is 4 plus V3, which is 2 plus I4 is also series with them, but we already we found already, so it will be 0.8 times R4, which is 1, plus I3, which is unknown, times R3, which is 4, equal to 0. I will see it now. So minus x times 4 plus 2 plus 0.8 times 1 plus x times 4 equals 0. There's something wrong actually. Here x, right? It has to be what? Okay. My calculator is lagging, so I'm waiting now for for the for the solution. So it is minus 4 times 4 plus 2 plus 0.8 times 1 x times 4. And what is going on? How? What are 2 and R3 are 4? Yeah, that's why it is giving math error. Actually, this question is tough because we are dealing with some misunderstanding of of the direction of R4 and R3. If it is R3 is going down, that means it is going here. But we are the but R but I2 is going down. So do we have to follow I2 or I3 or we just follow for its direction? I mean I2 if I2 is going down, so we are dealing with I2 that is going down, but here it's going left. So I don't know what's happening. I'm confused. So I will skip it. I will make a mark. So I'm going I'm going to returning to this question after I know the solution of it because it is necessary to know. Um, and the circuit showing EMF of a real battery is this, and this internal resistance is R. What is the power by the internal resistance? Okay, the power. Here we have the solution, but I didn't remember actually the the formula for the box, so I just make it the deep seek. So this is the formula. We are VHD. I think there's another formula. I don't know because if you want to, we didn't have R, so we are. It is given, but we didn't have I. But why is this V equal VR plus VR? I'm going to Blackboard to see the formula sheet because we already have it in the Blackboard. So I'm going to check and yeah. Yeah, so this is the formula sheet here. Yeah, we have it right here. Yeah, okay. It sounds great, but it seems not good thing because I didn't remember this one. That is okay. So this one, right? VAV equal E minus RI. So this one is about what? So VAB equal A minus RI. Ri is therefore for V, right? Yeah, therefore for V, which is you go here. Yeah. So what is VR? VR is given as 8, and we have to what? What is VR? What is VR? Potential drop across the resistor. Potential drop below that. Okay. Now it seems good now. Yeah, it seems good now. Here he said the potential drop mean what? He mean the VR, which is 8 volt. We have this one, which is VR minus VR, right? No, plus. Okay, plus. This is given as 20, and this is given as 8. So VR here, it will be 4. And after that, oh my god, what's happening? I'm sorry for that. Yeah, so. I don't know what's happening right now, but yeah, so VR will equal 4V, and the power is I square times R, or I square times R. So R we have it, we can have I. So I R. I, it will be V over R, which is 4 over 3.2. So here 4, 3.2 will be 1.4, 1.25 ampere. I so here it will be what? It will be 1.34. No, what? No, yeah, because it's square, it will be 5. So here it will be 5. So, so the thing is, the potential drop has been PR. But I'm gonna ask what is VR and VR? This is the potential drop across the external resistor, and VR is potential drop also, but across the internal resistors. Okay, that seems good actually. He doesn't mention. No, he mentioned it. Internal resistance. But he what? I think there's something wrong here. I mean, oh yeah, I should archive it here. That means the archive it. Okay. I'll come back within 2 minutes. Yeah, I'm back. Yeah, so this is for yeah, that means we have VR and V small. So VR voltage across external uh, external what resistor, and VR voltage across internal resistor. And sometimes he will give it to you like they give you R capital or small like this one. He said throw resistor R capital. This one you want the what fraction? What fraction of the current I passes through the 3 ohm resistor? So the I that will flow that will pass through 3 is the same I that will pass through 9 ohm. So um 3.4 3 over 4. So okay, this will be I here, I here. I mean I is the same I for 3 and for 9 I. That's what I mean. I don't know because okay, fraction. I'm sorry. That means um maybe like this. I'm so confusing. So I don't know what you mean with fraction because yeah, because we can't make a fraction. 9 is the same I with 3. I mean the current that will pass through 3 and 9 is the same. I will check it now. بس لحظة. Wow! I was, I thought it was serious. I'm getting cold. Already I'm getting cold. I forget everything. I forget everything about all this chapter. That is ridiculous. So yeah, yes, it will be like this one, and you will find I. So what's happening here is that for I, the potential to be 1 over I, I mean the sum here, because you are dealing with R, right? So R is equal I over V. It has to be like this one. It has, I don't know actually, it has to be like this. 9 over 4. And what we have? He asking about R or I? Oh, the current. Oh, I'm sorry. Okay, then the current will be I1 plus I2. And for I, it will be I1 to be V over R plus V over R. I here it will be V over 3 and V over 9. So 1 over 3 plus 1 over 9. And it will be 4 over, no here 9, yeah, so it will be 4 over 9. So V 9V, and for resistor, so V we know it now, V is equal 9 over 4I, but we didn't know the I, that is the problem here. If for parallel, you know that we have same I, yeah, it has to be like that. I mean, same by substitute I1 equal V over 3, so 9 over 3 will be 3 over 4. And the fraction, normal I, and will, mm, so after that, I1 is equal V over 3. So 9 over 4, 3I to be 3I. And we have to find I1 over I, 3I over 4 over I, it will be 3 over 4. So this is for the fraction. So fraction I1 over I, it will be 3 over 4, right? But we do, okay, but you see that you want I1. 3 over 4, okay, that's fine. Substitute. Mm. I didn't have to write here. I have to write in the OneNote. It's better. It takes a long time to delete everything. Yeah, I will solve them on my iPad. Yeah, so first you want the fraction of the current I that passes through 3 ohm. Yeah, so it will be 4/9 volt. And V it will be 9/4I. So I equal V over R. V which is 4 over I over R which is 3. So 9/4 over 3, or I mean 1, yeah, it will be 3/4. 3/4I, or 3/4, yeah. And now we have to find I1 over I, 3/4 I over I, which is 3/4. And yeah, that's it. I will move to this to be the last example. Yeah, so now last example right now, wires below are made from the same material. For each of them, their dimensions are shown in the figure below. Rank their resistance from the smallest to large. Yes, so we know something that we have B L over A, that's for R, right? So any of these, okay, so we will comparing L. So when L is more, it will be, so this will be in the top. So this will be 2 and 4, and we will see, okay, so we will see now for everyone. So for 1, it will be B L over A. So L over A, what is it? It will be 1 over 1. Um, 1 over 1 over what? 1 over pi 1 square. It will be 0.31. For the second one, it will be 2 over pi square 0.6. Third one, it will be 1 over 2 times pi square. It will be 0.007. 0.07. Fourth one, it will be 2 over 2 square times 5 will be 0.50. So the biggest one here is first one R2, R1, R4, R3. It has to be like this. It has R2, R1, R4, R3. So I'm starting from the largest to smallest. So we will notice that R2 is the biggest because it has the long L and small r, which means if you have more L, resistor will be more. If you have 2L, it will be 2. That's why, because R3 is the smallest, because it has 2R and lowest length, or the small length. Okay, we will stop here. We will taking this all. After that, we're trying to figure anything that we can do to be ready for the quiz. Okay, I'm going to I will stop right now, and I will come back within 30 minutes, 15 minutes. Okay, so we will continue. If 5 times 10 power of 21 electrons pass through 20 ohm resistor in 10 minutes, what is the potential difference of the resistor? So we know that having something called Q over T. It was I think. I don't remember. I'll check now. So something Q with T, or yeah, something like that. I can't find it, but it was having something like that. Yeah, Q over T. Q over T. Yeah. So first we have to find I. T we have it, right? We have it. So I will find I. And 10 times 16. And this I we find 4V times 20. 1 point. No, it's not. Electrons. Oh, yeah. Equal Ne. So 5 times 21. times 1.602 times 4 of negative 19 over t, which is 10 times 60, and this times 20, yeah, 26.7. So this is n over t, and after that v, it will be v equal I times r, 26.7. Okay. This one, 2 copper contains 3 electrons per cubic cover wires with area, and the electron drift speed is approximately. So, في let me check. Something with V, yeah, this one. I equal NQVA. I equal NQVA. So V is equal I NQA. Yeah, and Q it will be NE. And N for what here? What? Yeah, okay, it's fine. Q, I don't know what's happening. How N times N. So NQVA. Here already we have A, right? And J. We have it, right? So we can find J. After that, we find V, which is N over Q. But what is N? N 1. Okay, I think we can find it by this one. I think, I don't know. Let me check. 1 over 1.602 times 10 power of 19. 7.4 times 10 power of -7 times A, which is, or Q, which is 8.4 times 20. It will be 1.0 times this one, I think. No, this one. It was 1 point times -4. Maybe 1 millimeter. I will choose this one. I will try to be sure. 1 over what? A, which is 7.4 times -7. And after that, this 1.602 times -19 times Q, which is 8.4 times 10 over 28. Same thing, yeah. Okay, so in this example, let me check here. So we use two thing here, and this would be what? This is directly, okay. I Q N A. And there's another one which is J equal I over A, and then V equal J over NQ, which is here, NQ. Both of them I saw that it was this one, but I don't know. It's uh, maybe be right. Maybe it's right. It has to be one or this one. I don't know. So I will check it now. Okay, set 10 or possibility 4. I think because yeah, I think because I don't know. Yeah, same thing. Same thing what I do here. I do not. I received a different result here. One point zero zero times 10. So it is how is 10? If it is 1 times 10, I don't know why we didn't choose B, because It is 1. Oh, right, because 1 times something, it is like nothing but 1. I forgot about that. Crazy. The current in the battery. Current in the battery? I think we have to find by this one. I don't think so. So it's in town. I will see, because I don't think so. I don't think. No, it's not. AB, which is external. 5? If it is 5, I am such a great student. It has to be 5, actually. Yep, I'm a great one. Yeah, 5, yeah. So, this, it will be VR. And here we have I and R. This one will be 31. And VR 21 because it is the external. So I times 2. I will be 5 ampere. Second one. Two resistors of values 6 and 12 are connected in parallel as shown in the figure. This combination in turn is connected in series with 2 ohm rated, no, sorry, a 2 resistor and 24 battery. What is the power dissipated in the 6 ohm? So you want the power. Power is, I think, from this one. I don't know actually. He did not give us a. I don't know. It's not. It's not at all. B is equal something like I by square or yeah. B, what is B? VAB I square I, yeah, I square R. And he wants in 6 ohm, which is this one, right? But we didn't have I. Let me check here if the voltage in here in parallel. So we have same volt. 24 maybe. Maybe 24. But we didn't have the same I. I I will check now on my calculator. So 24 equal 6 times x, it will be 4. So I is 4, 4 squared times r, which is 6, 96, it has to be 96. So I is equal 24 over 6. It will be 4, I think. Yeah, 4. I will just be back within 2 minutes, 3 minutes. I hoping this will not be. I hope the screen is. Oh my god. I hope the screen will be fixing. I don't know what's going on, but maybe it has to be right now. It's fine. Okay, it's fine now. Okay. Thanks God. Okay. So now we will continue this one. So yeah, it's telling us. Oh, it will not be 96. So first we have to find R, which is R2. R2 and R1. So it will be series with R3. B1 will be, okay, same thing what I do. I1 will be 60 over 3. And how we get 3? 60 over 6, okay. It is not logically to. What? How 42.7 will be 43.7? That is ridiculous. Because it has to be 96 actually. Yeah, because R, we have already R. Voltage will be the same here. Because we are dealing with parallel. And we have, I don't know. We try to some things. See, and I will know I want to know how he react to this. Yeah, I have to check actually. I don't know if there's any wrong with this, with these answers maybe. But here what we have did, we try to find the R total, R parallel, and then the R total. So he will deal with one resistor. This resistor will be I6. So it will be V. So V parallel, V total, 4 times 4. Because this will be 4, will be 6. It will be 4 and this 6. But he will dealing with just the parallel one. So it will be 16. And 16 over 6 will be 8.3. 8.3. I will just I don't know. I will be I don't know, but I'm gonna make a point here to know that if my is true or not. I will ask my friend if he know anything about this. So I'm gonna ask him. So this one and also the first one. Here we have two large parallel meter plates are 0.8 centimeter apart and have a charge of equal magnitude but opposite sign. And their facing surfaces. The potential difference between the plates is 5.5. What is the electric field in the region between the plates? So two large plates, let's call these smaller plates. So we have these plates that are parallel and here the length of electric field is actually I don't have anything. Volt over what? Volt over I will check. I'm gonna check. Trust me, I'm gonna check. 5.5 over what? 0.8 times 10, 600. If it's 600, I don't know what's happening. V over V, right, okay. So it is delta V over V. Maybe the question is from the previous chapter, maybe. Is it the charge density on the surface of a conducting sphere? What? Charge density of the conducting sphere? Charge density, it was what? Oh, I forget. Charge density. Actually, I'm forgetting the formula. The formula, so I have to be sure that I'm not losing anything. So is okay, okay, yeah. So E is equal to sigma over epsilon naught, and sigma is equal to what? Or charge density to be E epsilon naught, and E is equal V over D. So yeah, V over D will be 0.100 or 0.1 B okay, and this times 8.5 times 1.4 times okay, it is 1.4 times 10 power of negative 8. Maybe there's something wrong here. I'm not sure. I will see. Yeah, I'm telling you this file, yeah, I mean this file is containing some of of, of question that is covered in the previous chapter. Anyway, it will be 1.4. That's ridiculous. Same thing, same what I do here. But I don't know what's happening. Maybe I forgot 190. Let me check. Yeah, oh my god. I forgot 0. This thing gonna be my. That's ridiculous. That is ridiculous, actually. Ah, okay. Next, the figure below shows a single loop circuit. The EMF and the internal resistance of the real battery shown in the figure below are what's this? E? Okay. And R. Okay, if a current I equal 8.3 ampere is drawn from the battery where a resistor R is connected across the terminals AB of the battery. What is the power dissipated? Okay, we want the power. We know the power we have. For the power, we have VI because we don't have R. We have R, but I square. Here because he give us E, and I can dealing with this formula. So yeah, it's fine. I will do this one. So this is B, V I. I have I. I don't know the V. So he said that correct the term with AB. If current I equal 8.3 is drawn from the battery when a resistor R is connected across the terminal AB of the battery by the resistor R capital I. So here we have R small and here we have R capital. This R small, we have these I R and R small. Yeah. So B for R capital will be minus VR and it will be minus I R I what I R yeah I R yeah. It will be 53.5 and B will be 53.5 times I, which is 8.3. It will be 4440. Yeah, it's 4.05. But he assumed it will be this one. I don't know why. Maybe it's wrong. I don't know. I don't have any idea, but it will be like this. So here, yeah. So most of these questions we have, we take this E equal VR and plus VR. Yeah. We have this one. Calculate the internal resistor R, which is what? Which is VR small with the battery. We have this connected to a load R and ground. Okay. I will solve it here. So you want what here? Resistance R minus VR. This it will be I don't know. In the formula we didn't have something like this. I mean, where is it? Yeah, we have it. We have it actually. Yes, we have it. So to find what here we want the distance. Okay, R equal over what? Over I. So here 3 minus VR. We don't have VR, right? So VR is equal what? 0.27 times 9. And over I, which is 0.27. 2.11. 2.11. So we have this. So we have this formula. And we have this formula. They are the same, yeah, but to be sure. 2.11, which is C. This one. When a potential difference of 10 volt is placed across a certain solid cylindrical resistor, the current flow is 2 ampere. If the diameter of this resistor is not triple. So you have VI, which is I. We have to deal with I, right? So I equal V over R. He said if what's happening? طيب, if the diameter of this resistor is now triple diameter, which is what? Diameter refers to A. Yeah, I think because R equal B L over A. And by R square over L. I mean L over by R square. If it tripled, okay. If it tripled, what will happen? I equal 10 over 2 to be 5. I don't know. So diameter of this resistor is triple, which is R. So triple means 3. 3 square 9. So R equal B L over 9 by R square. Now we can replace R with what? Assume L and B is constant. So it will be what? R over 9. How is that possible? How I equal to? Yeah, okay. I equal to. Here VR. B over what? 1 over 9. It will be 9V. So I equal 9V. To find I equal 9 times V, which is 10. No, it's not true. Uh, I didn't get this point. Here's BL over A. R is equal 5. Excellent. Okay. R naught B over L, it will be 9. Okay. So R over 9. Ouch. Okay. So here R equal V over I. 10 over 2, which is 5 right? Here he said we have a new resistance and a new area. So new resistance will be what? And this is the question. B L over 9, right? 9A. That means R over 9. And that's my question. Why is R over 9? It will be 1 over um let me check oh yeah, I mean because he said R naught over R equal um 1 over 9 A, we have A. So if you want to find R, it will be 1 over 9. So it will be R over 9. And we have an R naught. So R naught is R over 9. And then R naught will be the R, which is 5 over 9. And it will be 0.55. He asked for the I. So I is equal V over R naught. V10. And okay, so it will be 18 ampere. Okay, I will solve it here if I could. So now we have something called R, which is BL over A. If this will triple, so that means R will be B. Here we have 9A, and we have L. And so this is the R naught, and this is the R. And so if we have R naught over R, so it will be 1 over 9, and R naught will be R over 9. R, to find R, you have to find V over I, which is 10 over 2. So it is 5. So 5 over 9. Here it will be R naught equal 0.55 ohm. And he asked for I. So I naught, which is a new current. V over 0.55 5, which is R naught. So 10, same volt, but we change the R, okay? That will be 18. 18.00, it will be 18, and this is how we calculate it. This excellent question. Let us move here. This one, and 18.2 device has 9 volt. Across it, how much charge goes through the device in 4.26 inch? How much charge? We have V and we have W. We know that we have B equal IV. So I will be B over V, which is 18.2 over 9. So 18.2 over 9, it will be 2.02. He asked for a charge, so we know that I is equal Q over T. So 2.02 equal Q over the T. What we have T? Okay, 4.26 times 16 times 16. So the Q will be 2.02 equal Q over 4.26 times 60 times 60, and it will be 3000. It will be 30978.22. We can write it as yeah, we can write it as 30. Yeah, 31 times 10 power of 3. So it is this one B. Yeah. The current voltage graph of 3 wires are shown in the figure below. Rank the wires according to their resistance, greatest first. I over V, which is 1 over R, right? So the slope is 1 over R. Wire, okay, so the more slope, or the more, I mean, yeah, we can see the more slope, the more it will be less. So the less one will be the greatest one. So wire 1, 3, 2. Yeah, because 1 over 1, 1 over something. Yeah, and this one. Okay. A current of 5 times 10 power of negative 10 and exists in a copper wire whose diameter is the number of charge carried per unit volume. Assuming the current is uniform, electron drift speed. Yeah, same thing what we did. It was something. So see, where is it? So we have J, and he want what? V. So we have J equal NQVA. We have A, or we can find A, and we already have volume. I mean, J is I over what? Over A, right? I think I'm wrong because we don't have. Wait, it is J or I? I will check now. I, which is 5 times 10 of negative 10. Here we have y times 2.3 times 10 power of 3 divided by 3 square. So this is j. J equal 1.6296 times q charge. We don't have charge, right? Or we have charge. I think we have charge, but we don't have j. Let me check. 3 square. This is a. So 49 times 10 power of 28 times Vx times what? Times t? I don't know actually, because j is equal. And this I. We didn't have a, or we have a q, not n. I. We can find j. I over a and j over nq. Let me check. I over a, which is square. So this is j. And j equal what? Or v equal what? Equal j over nq. Over nq. And q what? 8.49 times 10 power of 28. 2.1? What's happening? Here a what? Here he divided by 4. Why? J equal I or a. V equal j over nq. I divide over 4. Over. Square over 4. Then this over أيوة صح. 90 divided over 4. So I will check y divided over 4. I will check first. I will check quickly. So which is confusing. I will stop here because I have to know how to calculate this one. He said that R is equal D over T. By D square? It was R, not what? Why he write D instead of R? Or this is formula. I have to finish quickly. I will return to this one, and I will kill myself in this. Look here. I will stop here. لا. So I equal A V D and A equal pi r square. Figuring D to be A equal pi D square over 4. So I will find J, and this is J. So J equal I over A. And A here is A point. So we have the first. We have J over NQ. I will use something else. I will use this one. I use this one. I that's why. Should say I not so it's 5 times 10 power negative 10 equal to 4.15 times 10 power negative 5, 1.02 negative 13 and 8.49 times 10 power of 28 times x will be so it will be 8.85 times 10 power negative 15. So it is n. So it is I equal NQVA. And and this is for the emitter, this is for R, this is for the emitter. And also we have this J equal this one. So it has to be something like J or so here V equal to J over NQ. This is I, so here I. Okay, so here it is I. So J, we have J equal I over A. And then we can calculate I is equal N Q V N Q V N Q V N Q V. What? N Q V A. So you don't have to find a J. That's not necessary. You just find A. To find it is pi, and he gave us D instead of R, so it is pi D square over 4. And it will be 8.85 to be 8.9 times 10 of negative 15. This one, however, is this length and A and first it carries a current of 3.4 ampere when a 2.2 V potential difference is applied between its end. Calculate the conductivity sigma of the material of which this wire is made. So he wanted the conductivity, which is sigma. You know that sigma is equal to Q. I think it was sigma Q sigma above sigma. Yeah, sigma E epsilon naught. So E equal sigma of epsilon naught. So E equal E of epsilon naught. And to find E is 11, but V over D. So E is V over V. Um, yeah, I think that's right. V over D over D. So I will calculate it now. So V 2.2 over D, which is 1.4. This times the permittivity. 1.3? No. I think this is not this is the length. Sigma equal J over E, and we know that sigma equal IN over VA. Sigma over E equal VD, radius, give us the length. What is this one? I don't know how we figure out this equation. Sigma equal JE, J equal sigma E. What? Let me see. J over E. So as you write sigma equal J over E, sigma to be. So here J, which is sigma, or J equal IA. Okay, that's fine. It will be over L. So sigma or J over. Okay. Here wire is 1.4 long and 0.72. So sigma is J over E. We know that J is over 4J is equal I over A. So what's complicated here that I didn't take, and yeah, I didn't take sigma equal J over E, but yeah, so J equal I over A. Here we have new thing that J equal sigma E and E equal V over N. So sigma equal J over E. J is I over A. E is V over N. So it be I over A times to be L over V. Yeah, L over V. And we can, yes, we have I, we have V, we have A, we have L, and just yeah, directly. Here we have for the circuit shown in the figure, the current in 8 ohm. So this is one. So this is in parallel. 8, 16 parallel, and the I is 0.5. That means 16 is not 0.5. Was the current at the 2, which is here? What? The current in the 2 ohm. Actually, we can. I don't know. Maybe take the R equivalent for both, and it will be series. This one, this one will be series. This and this series, and this in parallel. So this and this in parallel. Yeah. So this is 20 ohm, and 60 ohm, and 8 ohm. This is 6 ohm. R equivalent for it will be 1 over 16 plus 1 over 8. And this one will be 1 over 6 plus 1 over 2. Over 16 plus 1 over 8 will be 5.3 ohm, and this one will be 1 over 6 plus 1 over 2. It will be 3 over 2, which is 1.4. So, it will be like this, this one, yeah, this is 20 ohm, 5.3 ohm, 1.5 ohm. But how we can find the current? The current into, if it will be the series, so it will be the same, right? And we end up with 1.5 ohm. But it's in parallel. I don't know. It's in parallel. So when we compare to the series, it will be the same. Maybe it will be the same. Maybe. I don't know. Also, they are not giving us. He said 0.5 ampere for 8 ohm. That means that there's something with this that will help us to find the current in 2 ohm. Anyway, I will see the results here. Because I messed up, I think, yeah. Technical viewers. So here, yeah, 0 point, okay. V8 will be, okay. And for parallel, it will be same, صح. So, yeah, it will be 4 for both. 4 volt for both 16 and 8. And the current is a series with a combination total current supplied by the source. Here you find this one. Or combination. Take the R equivalent here and the R equivalent here. So it will be R equivalent. Okay, we already take it. It will be 2 and here 2. And we end up with this one, which is negative. And here we have this one. So this is 5.320. And here 1.5. If we take this, I think if we consider this I and the lobe, it will be like this. So do no, no, no. The second I don't know what's happening, but it just makes me confused. I will see someone you can solve it, because I cannot actually. If we take the R equivalent from here and the R equivalent, so we end up with series. If we take this one, the cube one, we don't have voltage actually, but we can't find the volt for this one. Maybe it will be the same. For parallel, yep. 1 minute. So 4 volt in this 4 volt, and if we take the equivalent, we have R, but we have no, yeah. 1 minute. We have this I. Don't have this one, but we have V. This is in series, in parallel. Maybe R equivalent. Maybe R equivalent because 1.5 or 5.3 equal to 4 because we have same. Here 8 and here 16. Negative 1. What? This volt, right? 4 volt because voltage would be this way, but maybe it will go downside. Yeah, makes sense. So I will capture this one and I will ask my friend. And I'm gonna post every question that we didn't answer it. Show this one. Clear. Okay, I will draw here like a point or sign. The resistivity of gold. So we have lots of questions. Okay, الحمد لله في solution. I will ask. I will ask if he has a solution for this one. Resistivity of gold is this. At room temperature, a cold wire that is 1.8 millimeter in diameter and 11 the length. Okay, they have AI. How much power? Yes, it will be I, but R equal B L over N. Yeah, it's easy. Here we have D. So it will be, so it will be, let me write it here. So 2.44 times 10 power of negative 8 equal B, which is X, times L, which is 11 times 10 negative 2. And we have A, which is pi, times V, which is 1.8 times 10 power of negative 3 square and all over 4 because it's given it in diameter. It has to be one of these. Here, here it gives 5. No, it's not 5. It's not 5 at all. He gives to us the. I don't know. We have to be sure that this is the power, not the. So here, no here. electrical power. How much power? So you know power is I square R, right? Maybe this, yeah, maybe. Yeah. And we will not convert M ampere because it's given M power. 4.1. Something wrong here, I don't know. No, it's not. I'll read it again. Maybe I messed up something. Here we have resistivity, which is R. Okay. I think mouse is not charged. Yeah, okay. Yeah, so here, going with that, here we have the loom here, which is L. Here D. I will let my mouse charge. After that, I'll be back. So this is M, D, and we have this is I, right? So how much power is this B? So we have B equal I square. So yeah, I square R. We have I square. I don't know what's happening. I forget R square. No, no, I didn't forget it. Same thing. One minute? No, no, it's not correct. Power we have many things here. Let's check here. So here we have E over J. Okay, so B equal VI. We don't have V. We just have I square R. So I is given, but I don't know what's happening. Like something wrong here. B square over R to be I square. I square over times R. I will check because it is. I don't know what's happening. It's given us the the current and R is given. We just swap it directly, but I don't know what's happening right now. So I will check here. Mm. So resistivity of gold, it is, yeah, current length. Okay, I use the same thing, but it's impossible to cancel. What? Resistivity is B. Wow, that's ridiculous. Resistivity, which is B. So we have R equal B, resistivity L over A. Wow. Find B. Thirty. 30.4. This is down convert 170 to MA. So it will be 0.8. Here he didn't convert anything. I square. No. So I convert it. He converted 0. So 0 times 10 power of 3. And this is. So tell, okay, I get it now. I get it. Activity is B. So this is B, we have B and K, so find R and replace T. Or so the equal to beta, so it will be pi e square over 4. Outside is established from a battery from B to N. What is the voltage V? Fine. So equal VR minus VR. This is I R. This is N now. And we have the 25 equal x minus 7 times it will be 74. Plus VR plus 7.7 negative 24. This is negative 24. VR, I don't know if it's fine to about the negative. How? Square. Tell me 3.75. This one. So this is 1 with 3. And then which is B. We have A. Count. And we have sigma over epsilon. You can find the for A to be V over R. We can find R as V N over because we have equal I x over a. 8 we had diameter, so 9 times 1 times 10 power of 3 square over 4. B over Okay. Okay. فين قاعد تشتغل الحين؟ فيديوهين. 3D over 4. Over 4 BD. Find B. Circuit register search resistor and battery resistors taken. Okay, that means resistor. Otherwise, this again 500 millimeter. First resistor, the second one is R equal B and R half a meter R square. This will be B R over R square 2. So R equal to a safe electric heater consumes 24 kW. It's connected to the resistance. Resistance let's have a look at this. B B equal B square over B square over B. To go to resistivity, speed, and curvature is this, and this is the 4.6. No. Okay. Let's take this out, B very over here, and then find J, which is I over and E equal to over J over sigma. R will be 4.3 and J 3 over 5 0 times 3 square times seven over 2 whole 12 times 10 power of negative 8 3.6. Uh, J over sigma. Sigma is 1 over resistivity. And from J is I over A. A is pi A square over 4. 28, 553. Yes, I agree. A and B. Tension difference. Difference is times 8 plus 44. This one bonus 6 6 square. 6 times 4 square. This one is 6. R6 and okay. Okay. Five from diagonal so far. 16. 16, so I have distance 8. H minus 60 interviews closed. Switch is hours at the same time the battery is energy speed. Series equivalent. So this is in parallel. After that we will have series both of them, and this will be in parallel. So this is series, and it will be series of parallel. Over 20 plus 1 over 16 times negative 1. 30. So 1 over 30 plus 1 over 20. Or negative 1. 12. So it will be 12 from smallest current has traversed the storm. الحين بخلص بعد شوي. شوي. Smallest current has traversed the storm. So I equal V over R. The resistor was small resistor will be the one but this resistor on the big value will mean it will have a fixed count, which is 16. The smallest count would have the fixed value of resistance. Thirty. 1 over 20 plus 1 over 30. Or negative 1. 12. Okay, for the second one it will be 16. right. It's kilowatt hour meter. Should drop energy. The current power. I think the power. Yeah, it's power. Which one the combination of units presented on so V over R is equal to V over R over I. That means volt over ampere. Then because I is equal to Ji, J, so this B over A. Yeah, so second energy for unjoined current and their ELV, and also the energy B equal V times time B times time into this. Minus since I is equal to Q over T. force what according to you and second. How would you know care about the time which is big. Equal BT. And here it will be all or B. Reason has is strong. The tool of the power displayed by each is the same. I think yes. No, it's not. The total current through the resistor is the sum of the current through each resistor. It's not the sum. No. The current through each resistor is the same. Yeah. Through the voltage across each resistor is the same. No. The rate at which charge flows through each resistor depends on its resistor. The rate at which charge flows 16, which is our Einstein's choice result, is in a conventional electric current that flows northward. So conclusion, I think I'm scared. 3, 4, 5. The electromotive force and potential resistance of a battery are is shown in the figure. If a current of 8.3 A is drawn from the battery when a resistor R is connected across the terminals AB of the battery, what is the power dissipated by the resistor R? So so V R capital minus I R and E. For R, I R, V minus V R. So when I unify R is unknown, we have I, but why it is I plus R? 95 6.3 times R. The AB is unknown. We have R, which is 5. So this times 8.3 squared. The internal resistance shown different below. The internal minus IR, if we take for loop 1 or loop 3, loop 3. And the voltage VR minus IR. This for this question. Yeah, as I said, that is 6 here and solve it as 36. Oh, wow. After you find VB or VAB, which is V minus IR, we find R, which is VAV over I, and then we find V, which is I squared times R. This one, I don't know. Here, for the term or quantities are accurate to a significant figure on the value of the count I1, I2, I3. I assume this will be the I, the sign, and this the loop. And thus this is the loop here. And this is the I. And you have to take all of these. You have three equations, one for junction law, and searching this point, you can take this point. And you have three equations, and you can rewrite them and put it in the calculator. So uh, you will end up with the quantities for the K or the value of the free current. For this one, I will see it. Electric field strength, volt over meter. Electric force, Newton. Electric power, watt energy. Yes, energy. That is energy. Electric power is unit of percentage defines V. So definition is many questions that don't answer. Two core contains 8.4 times 10 power of 28 free electrons per cubic meter. Cross-sectional area. This solid will okay. We have this quiz. This quiz for my doctor. So I'm going to show it. So here, the light bulb is rated 13 watt, 30 watt, when operated at 120 volt. How much charge passes through this bulb in 1 minute? Okay, so you have here, I will delete this. Here you have V. You have V. How much charge, which is Q. We have something as Q over T. And this was for I. We have E equal V square R. V square I. Yeah. V square I. I think. Check if it's right. V square. VI. Okay. So it is VI. And I is Q over T. So we have Q. So we don't have Q, we have B. T would be 60. So that is 120 times Q, which is now over I, which is or no, which is Q over T, right? So Q is now T60 equal 30. So this has to be 15, right? Wire has an electric field wire has an electric field of E equal 6.2 V over M, and the current density, which is 2.4 times 10 power of 8 A over M square. And here the resistivity. The current density, which is sigma or G? Or G, okay. So we have R equal B L over A. And we have sigma 1 over B. So we have A, right? No, we don't. We have less T. We know that J is equal sigma times E, which is 1 over B times E. So 1 over, also he asked about the resistivity. So we have electric field sigma, and we can take the sigma. So sigma is, so current is 2.4 times 10 power of 8 equal sigma, which is a noun, so it's x times 6.2. And yeah, so we have sigma and sigma equal 1 over b, which I know. So it has to be 2.6. Yeah, so it's 2.6 times 10 power of 8, negative 8. So here I use that sigma is equal 1 over b, and we know that E or J, here J equal E times E sigma. And I don't know if he added or no, I didn't mention this one. So it has to be a sigma equal 1 over b and E equal what? J and J. So J equal sigma times E. After that, you can solve for B and find B. This one, the electromotive force and the internal resistance for battery are shown in the figure. The current in the circuit is 1.5 ampere, which is the terminal voltage V equal V minus I R. 25 equal VAB, which is a now, minus 7 times 1.5. 30 minutes is positive. 14.5. Here positive, I forgot about it. It always positive. Does he mention this? I don't know. Yeah, he mentioned it. For the circuit showing them the current in the two resistor. So you first we take this as our equivalent. So it will be this, and we have this one, and we have this one. And series is this. And then R is equal to V over R equivalent. So it will be 2.0. So this one more version. And when we take the argument, it will be like this. These are in series. So you can say your equivalent equal over R1, R2, R3 plus R4 plus R5. There's these. Two wires made of the same material have the same length but different diameters. They are connected in series to a battery. The quantity that is the same for the wire is here the current because R equal B L over A is okay for the meter. I think different is the meter. Yeah, because they are connected in series. In series we have same current. So the current will be the same. Okay, we finish it. Uh, 30 minutes left and I will quick revision. Very happy you haven't done VR, VR smart. And the ball is going to enter drops through the RV is 8 watt. So you want a VR, right? So VR is 8 watt. And you have VR smart. VR smart will be what? 12 equal 8 plus x, so x to be 4. VR is 4. But he asked about the power. So power I square, which which is I times or VI or V equal I R, and R will be 4 over 312. Yes, okay, we have VR which is 4V. Ask what about V equal I square 312 square times R. R what? We don't have I. We can find I. We have R. So we can find so 12 equal 8 plus 3.2 times X, which is R. So 3.2 times 12.9. Then I resist I is equal to 1.24. Okay, as let's find I. 1.25. So 4 is 1.25 square times 4 times 3.2. That will be 5. Okay. After we find the R, we will not use this one. Oh, we didn't have compare, so we have to find 4 over 3.2, which is 1.25 compare times 3.2. Okay. This one in the circuit shown below. Fraction of the passes from 3 resistor. If we take the equivalent, so it will be what? 4 over 9, right? So our equivalent is 1 over 3 plus 1 over 9, which is 9 over, yeah. So our equivalent is 9 over 4. To find the current, which is I, equal 1 over 4 V over R. We already have R, which is 3. So 9.4 times 3 could be 6.74. Or I'm sorry, it's 9 over 4 times 1 over 3. So it will be 3 over 4. This one. This one we will calculate for each of one. So this one will be R equal V L over A. So this is will be what? So assume R is 1 and L is 1 and calculate them. We have R. So Y R square and you have 2L. And you can find it. And this one is easy also. We have electrons pass through this R and this time. The potential difference. Potential difference here is IR. We don't have I, but we know that I is Q over T. Q over T, and electrons passes, so 5 times 10 over 21 over 10 times 60, and this one will be times 20, so it will be 6. Let me check. So this is electrons, which is N. So 5 times 26.7. Okay. So we have what here? We have the free electrons, which is N. I think it's Q because he said he's a per cubic meter. So V is I and Q V M. So I this one equal 6 times 8.4 times 10 over 28 times V or A, which is 7.4 times 10 power of negative 7. And 10 power of negative 4. The electromotive force. Here, so VA, okay, for the current in the battery. So E minus or equal VAB plus IR. That's it. The resistance and surge I don't know much. This also, or not, we have this D, we have B. The charge density on the surface of a conducting sphere. So we have this radius, which is D, and we have the charge density, which is sigma. So sigma equal, yeah, we have A times E power times the permittivity. E is V over D times the permittivity to be 1.4. This one. So this one, and the figure below shows a single loop circuit. The EMF and the internal resistance of the real battery shown in the figure below are this E and R. We have I from the battery resistor. R is connected across the terminals AB in the battery. What is the power dissipated by the resistor R? This is the resistor R. And you want to find the power. More is VI here because he mentioned this. So E is equal VAB plus IR. We have I, we have R, we have to find VAB. So VAB will be 53.5, and you can find V. Here also the same thing. We have I, we have this. I can find, can I just tell VR small? Okay, so VR, it will be equal to A minus VAB and VAB, which is I times R. So here we have V, which is 3, equal. We have VAB, and we didn't have VAB, but you can find by, yeah, I mean, here you can say 0.27 times 9 plus AX 0.57. This is for VR. So you have, okay. So X times R, which is N 0.06. Okay. So he used this one, which is A equal VAB plus IR, and you want to find I. So it will be epsilon AE minus VAB over I. I mean, you want to find R, not I, R. Now potential difference of 10 volt is placed across a certain solid cylindrical resistor. The current through it is 2A. If the diameter of this resistor is now tripled, the current will be So R naught is equal B L over 9A. So R over 9. R naught will be R over 9. And the R here is 10 over, which is 5. So 5 over 9, 0.5. So 0.5 for R naught. Then you have to find I. Have what here? The I, D, and the volume. We can find I, which is in QVA. And ouch. So we have this Q, we have N, we have V, which is which is the velocity. We have A is equal pi d square r of R, and we have to find this one. We have A I, which is current, and N we have Q, we have A. So we just want to find V. A wire is this long, this area. The current is I. And volts, the conducting of the material, which is wire, is meant the conducting of sigma. So sigma is equal to 1 over V. We know that sigma is equal to J over E, right? So J is I over A. So we can find AJ. Now we have J, but we didn't have E. To find V or E, V over N. So V over N, find E. At the bit you can find sigma, which is J over E. At L we have I. How much power, which is B? So it will be I squared times R. We can find R by this one. So we have B, we have L, we have N. And for A to be by the square over 4. Electromotive force, then 10 resistance. Okay. The EMF and the Turner resistance of a battery are shown in the figure. If a current of 7A is established through the battery from B to A, what is then the terminal voltage VAB of the battery? So here we have this is a IR, and yeah, so we can find the VR. This one is have we have video screen. Here we have V. We have the how much current. So we have the so we can find sigma, which is 1 over V, and current, which is I. So J equal I over A. We have A, but we didn't have I. I is what? I is J times A sigma, which is 1 over V, and then we have J. Sigma we have it, here we have it, so we can find yeah, I mean J. And J will be, as you can find I by J times A. That's here we have a board wire that is 3 millimeter in the diameter and 15 centimeter long carries a current of 260 milliampere. How many electrons per second pass a given cross section of the wire? So here we have this one B, we have N, we have I. So how many electrons per second, which is N. So N is equal Q over E. To find Q, which is I times T. Right one will be V equal I in Q A. And A will be 4. Or because this thing it will be, yeah, it will be 4. And yeah, it will be 3.4 times 10.3. And for 4 it will be 3.14 times 10 power of -6. And so V it will be I over 4, which is 4 VD. The chrome wire is 1 meter long and 1 times 10 power of -6. In a cross sectional area and connected to a potential difference of 2V, a current of 4A ampere exists in the wire. The resistivity will be R equal V over I, and you can find R by V N A. I will stop here. So we are finished chapter 26, 27, and I will move this So I will move the file that it was containing the second uh, yeah, this one. This is a video that I will add with this video. So it will be, yeah, so it will take a long time to be here because it is 1478. Okay, let's it was a tough chapter, but we was uh, yeah. So by practicing, it will be easy. So we cover more in the slides and the book. Actually, we cover some questions. We cover two files of questions and one of them for the vector. We cover this notes and it was, yeah, it was a big day actually. We did a lot of things and tomorrow it will be for the programming. Yeah, that was to be 2 minutes left. I will check if this is right. It's fine. So this one we use V, which is V, or we use I to find I, which is Q over T, and we find V, which is V times I. Here we use sigma equal 1 over V, and J equal U times sigma. Here, this formula, we use it, and for this one, we want the current in the 2 ohm. So we take the R current here, which is parallel, and we end up with this series. So we take the R equivalent for 3 ohms, 3 resistors, which are in series. And after that, we end up with this simple series. Yeah. So you can find it now, and you can find I, which is V over R equivalent. For this one, he is asking about if we are connected in series and with same material and same length but different diameter. The quantity that is the same for the wires is the current, because current is the same in the series. I'm going to stop here after 1 minute also. But I want to know So here we have it. My laptop is heating. Okay. So I'll stop here. Yeah. Thanks for watching this video. I hope everything is clear now. We end up with chapter chapter 2, 27, 26. It was a beautiful chapters, and it's actually my favorite, starting from chapter 25 to 27. Let's talk about the capacitance, resistors, and the charge of. So thanks for watching.